Wow, now YouTube's working. Good job, YouTube. I'm so proud of you. Oh. Oh, God. What do they do to my camera? No, it's so bright. One sec, let me fix this. This is way too bright. Oh, can I not change these things while we're streaming? Really? That's a huge pain in the ass. What? Oh God, now I'm too dark.
Okay. I am Batman.
I am Batman. Wait, let me turn this down. Exposure's too high. There you go.
Kevin Conroy is the Batman.
Is he? Kevin Conroy?
Kevin Conroy.
Oh, Kevin Connery. Yeah. Sean Connery.
No, Kevin Conroy, the guy that did the voice for Batman for like 30 years.
Oh, did he? See, I'm not. Are you a big superhero guy? What's up, Ace? What's up, guys? I'm not a very big superhero.
I prefer DC over Marvel.
Do you like? Wait, do you prefer DC to Marvel? You said you like DC better than Marvel.
Marvel is, well, don't get me wrong. I like Stan Lee's characters. They're just a bit. I don't know.
Stan Lee, right? Yeah, Stan Lee. Yeah, he's cool. Right, he created all the Marvel
characters
stuff.
of realism.
Oh, I see. That's the difference with yeah, like Batman is meant to not really have like that much of superhero stuff. It's more like just technology, right?
Well, yeah, but I mean, even with like Superman, it's like sat there and spelled out. It's like, yeah, because he's an alien, and
right,
it's a different sun, and it does something different. But with like Marvel stuff, it's all, oh, everything's all fantasy and magic and
yeah. He got bit by a spider, and now he's Spider-Man. Right?
Actually, no, I do like that one.
That one is a little bit of an explanation. Are you talking maybe like Doctor Strange, like how Doctor Strange is Doctor Strange? Like how does that work? I don't know, maybe.
But yeah, but then DC does have its magic characters, doesn't it? But yeah, I find all that bollocks.
It's got a lot of plot armor on some of them, right? There's like plot armor, like they can't be killed. What is that emoji, Ace? That's dope, man. What? Gold, please. Twitch, dude. This is a great. Excuse me. Where is this emote from, dude? I need this emote. How did you get this gold one? What? Oh, this is dope, dude. What? Ace, how'd you find this one? I'm gonna spam it.
Global.
Dude, it's so cute. The hell? What's up, Zero? Anyways, yes.
Zero is not the name.
Well, yeah, his name was like Her Pleasure or something. Did you change his name?
Ribbed for her pleasure.
Yeah, did you change his name? Yeah, I was like one of my mods must have changed your names. Like cuz his name was like kind of like he's the one that had the fake OnlyFans link in his profile. And I was just like he's like it's a fake link. I'm like, "Bro, but nope, I'm not going to tell my mods to click like even a fake OnlyFans link. That's just weird." Like can't do that.
Well, even I sat there and said, "I'm not clicking that."
Yeah, and we're like internet veterans. I'm just like, "Yeah, I'm not clicking that, dude. That's not going to happen."
I've been there since the 4chan Gore days.
Yeah.
I've seen some shit.
Yeah. What was it? Goatsy, Tub Girl. What was Harlequin fetus? I think was the unholy trinity. Yeah.
Jesus.
I know. Yeah, don't look at any of those things, kids, please. Yeah, no. That's the dark days of the internet, dude. Yeah.
Actually, the dark days are coming back. Did you know there's a thing called
O says I'm a girl. Oh, my bad. I'm sorry, O. I can't tell genders, and to be honest, if you look at my stats on anything like Discord or whatever, it's like 90% dudes. So I assume most people on Discord here are guys, but I love that we actually get like women involved with this. Like I don't know what it is about like the internet and computers and gaming, but for some reason it doesn't really. I don't know, blame the algorithm. Yes, I appreciate. We have a couple really cool girls in this Discord. We have Ash. Ash is a longtime homie. Ash is fucking great. We got Rubug, she's cool. And then Evoli. Yeah, it's so awesome. We got another one. Yay, okay, cool.
It's just a male-female divide thing.
Why is it though, man? You know, if I look at my server analytics, right? I don't know.
Genetics.
What, girls just don't like computers genetically? Like, why is that? Like, that doesn't make any sense.
I'm not going to sit there and dissect the whole thing, but yeah,
No,
we're
I'm
all
just
about
curious.
mechanics, and they're all about empathy.
Oh, okay. Empathy and like emotional intelligence. Yeah.
Yeah, and
Dudes are,
so
we're pretty fucking
physical
retarded.
contact means more for a female than it does to us.
Yeah, we're pretty retarded when it comes to like, yeah. Because bro, if I go onto my like my audience, yeah, watch, I'll show you. Yeah, here. You when people say like, you know, like, oh, that's sexist, I'm like, no, dog. YouTube sexist. Then, if you look at my age and gender on my content, it's 85% dudes. So, that's why. Wait, user specified. Wait, are these the pronoun kids? 0.5%. That's kind of fun. Yeah. Mainly
Sorry,
18 to 20.
Exist?
It says user specified. I don't know. What doesn't? Oh, you're making jokes.
I said what doesn't
You're
exist?
making jokes, dude. Okay, but look at this. So, majority of the people that watch our content are 18 and 24. We got some 25 to 34-year-olds. I think this is just most kids don't actually put their age down. If you're under 18, you probably don't put your age down on YouTube because then it starts restricting you, right? Like you get restricted at what you can see. So I bet most of the high school kids that see my stuff just lie on this. So.
Well, yeah, from the earliest days, I'd put down the 1st of January 1900.
Yeah. A says, hell yeah, true.
That's dope.
But I'm happy at this. So, top geographically, so a big problem you'll see when people are buying views and stuff on YouTube is it'll all come from India or the Philippines or some bullshit. We're getting 48% domestic, which is pretty good. Canada's up there. Represent Canada. We got a lot of Canadians in our server, which are cool. I don't know. This is just kind of cool to see.
So you've got to take time zones into account as well.
Yeah, so these time zones. So this is actually cool. It kind of shows like when our viewers are on YouTube. So mainly it looks like I think we should start a Sunday afternoon stream because the data's here, man. Sunday afternoon is poppin', and so is Friday afternoon. I don't stream on either of those days, but if I'm looking at like my viewer count, Tuesday and Wednesday morning are pretty dead, honestly. Anyways, Ace says, I was born in 2K. I was born in 2008. I represent Canada. Nice, Ace. Yeah, I just put another video out. Let's see how it's doing. Where's like my content? Show me my content. Where's my content? What do I gotta do? I gotta click content. That's how I have to do it. What are we up to? Oh, shorts. Nice. Okay, cool. 1,000 views in the first couple hours. That's not bad. 93% satisfaction. Uh-oh, only only 50% like part 3. I hate this. YouTube makes it because shorts can only be a minute long. I have to split like a 3-minute video into 1-minute chunks. And it's always interesting to see like which part does better because I have like a part 1, part 2, part 3 when I split it out. In this last video, for instance, part 1 only got 4K views, but the last part got 10K. So for whatever reason, people liked the last third of the video versus the first. What's up, Billy?
I don't know. I'd say most people aren't stupid, but then they don't understand the more advanced concepts.
Yeah, maybe that's how that works. But here, for instance, like people really don't like 50%. This is terrible. This is not good for my This is not good for my algorithm. You want a lot of likes versus dislikes. But whatever. Anyways, you know, the content game continues. What's up, Laz? Ooh, 35 stream streak. Congrats, dude. What's up, Equity? Equity, did you ever get the keyboard that I sent to your friend in the US? Did you ever get that? Please tell me that worked.
Probably not.
Probably not. Yeah. I couldn't get the PS5 out to the Sri Lanka guy. I'm about to just sell it just to get cash and then just pay you guys out in gift cards. I'm just finding that physical prizes are difficult to get to people. Oh, keyboard's hitting the soundboard. Anyways, okay, cool. Looks like we got some good questions today, so let's roll through them and kick off the stream. All right, welcome around with Office Hours. My name is Dr. Golden Sachs Education. The stream helps you with math homework, science homework, all sorts of fun stuff today. Shipping to Sri Lanka got to be expensive. Yeah, I mean, and I told the guy who won from Sri Lanka that so when we did our big competition, I had a bunch of digital prizes and physical prizes. Obviously, the best prize was the physical PS5. But like the second best prize was a $100 gift card. I told him to pick the $100 gift card because I can send gift cards. Those are easy. But he still picked the PS5. And I was like, okay, bro, but you got to have someone in the US I can ship it to because I'm not shipping a PS5 overseas. It's not going to happen. And he still messed it up. So whatever. You live and you learn. I think I may stop doing physical prizes for stuff because it just doesn't work. I do economics. Yeah, sure. I can help you out with economics, Zero. That's totally cool. Here, let's help out Ace. Ace asked one of the first questions. Well, did anyone... Oh, Zach asked a good question yesterday at 4:40. Is Zach around? Zach, you're a new student. I love when new students find us and, like, ask questions. Zach is Zach, you around? Yeah, asked a question yesterday at 4:40. I think that's right when we were ending the stream, honestly. Unfortunately, yeah. Anyways. Okay, here, let's put what Ace has got. This looks like some... Oh, this is power. We got more kilowatt hours going up, Ace. And yeah, Zero, feel free. Post as many questions as you want. I make sure I go through every student's question at least once. But we usually have more time, so then I can go through additional questions. Yeah, it's totally cool. Let me make sure that... Yeah. Cool, that's working. All right, nice. Loading it. Big screenshot. Can I pop this out? Can I pop out this chat? Oh, nice. That actually works. Wow.
I'll just sit here and spam random memes for the next half an hour.
Yes. I appreciate the memes. Sensation. What's going on in good old English, sure? Anything cool? We're about to have an election over here. Are you guys following our election? I bet it's kind of cool, yeah?
Not me personally, but everyone else is complaining about it.
Yeah, what are they complaining about? Orange man bad? Is that what they're saying? Orange man bad?
No. Labour thinks Orange Man bad, so Labour is evil. That's basically how that's going.
Oh. Is Labour like the liberal side? The lefties? The lefties of
Labour is literally what it sounds like. They are the nationalist, not the nationalist party, the socialist party.
Oh, I see. Okay. They're the working class, usually, right?
Supposed to be.
Supposed
really not.
to be. Yeah, dude, politics is all messed up with, like, you know, who... It's weird, right? Because, like, the Republican Party, for whatever reason, tends to do very well with very rich people, obviously because being fiscally conservative means rich people get to keep more of their money. But they also do well with really uneducated people. So I don't understand that one. So you got like these really rich people and these really not conventionally well-educated people going for this party. Whereas, yeah, Democrats usually take the middle of the road and the very highly educated. And it gets weird with the poor thing, right? Because poor people benefit from Democrats, but also they like voting for Republicans. It makes no sense to me. I don't know what's going on. Yeah, tomorrow is conservation of energy and work energy. All right, let's do it. All right, here we go. When comparison shopping for a refrigerator, you compare almost two identical options, just varying by power and price. Super cool fridge, ice cold fridge. Okay. The average cost of electricity is 13.4 cents per kilowatt hour. Yeah, this is cool. So remember, we were talking about this yesterday, right? How energy can be expressed in like kilowatt hours. It's kind of weird because kilowatts is a power, but if you multiply it by a time, then you get an energy. Which is more cost effective. Yeah, what's up?
Sorry.
No, go on.
This is why I should have the camera on. Is it that joules is a derived quantity?
Oh, interesting. No, I think joules is a fundamental quantity because it's just energy, right?
Well, doesn't joules have some units, times units, which equals a joule?
Yeah, is it like a Newton meter per second squared or something? Let me see.
Yeah.
Yeah, Sensation brings up a good point. It is derived. Okay, so yeah, I'm wrong. Yeah, you're right, Sensation. Okay. Good. Yeah, joule is derived.
I'm surprised I remembered that was correct. Sorry.
No, that's cool. No, that's a good point. Yeah, yeah, there's what's called derived units, and is it a fundamental unit? Is that what it is?
What's SI?
Derived quantity versus I think fundamental quantity. Yeah, so it's whether where this comes from. It's like whether the amount is calculated or just directly measured. So for instance, you don't calculate the amount of feet of something; you measure the amount of feet something is. That's a fundamental unit. But if I wanted to measure area, for instance, right, that is derived because I take length and then I just square it if it's a square. But yeah, that's kind of cool. Yeah, I forgot there's a difference. Yeah, so joules is derived. You're right. Joules I think is it's newtons meters squared per second squared. Yeah. If you want to know where that comes from, it comes from, like, for instance, for kinetic energy, if anyone remembers, right? Kinetic energy is equal to 1/2. Oh, sorry, it's no. Yeah, 1/2 MV squared. Sorry, it's kilograms. And then this is meters squared over seconds squared, because velocity is meters per second. Seconds you measure, that's fundamental. Meters you measure, that's fundamental. Kilograms you measure, that's fundamental. Yeah, so sorry. This is the fundamental unit of energy. Yeah, sensation's right. Okay. Which one is more cost effective if you plan on keeping the fridge running for at least 5 years? This sounds like a bad like joke or something. Like, you know, what's the joke with the fridge running? Is your fridge running? Yeah, well, you should go catch it. No. Such a shitty joke. Anyways, okay. All right, Ace, how do you think we do this? How do we do this? Which one's more cost effective? This is kind of cool. Bum, 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 bum. I need to incorporate, Sensation, what you said about the AI music. That's a good idea. Actually, I met some chick at one of these events that licenses out, like, free, like, non-commercial music. I should talk to her. Efficiency. Okay, teachers taught some shit with efficiency. Yeah, that's okay. Yeah, we don't need efficiency here because we don't know what the efficiency of the fridge is. Yeah, that's okay. Efficiency, yeah, energy out over energy in. Yeah, so for instance, if we wanted to talk about efficiency.
Energy in equals energy out.
Times efficiency.
Waste energy.
Exactly, right, yeah. Yeah, and we talked about this, right? Energy in is equal to like useful or energy useful plus energy waste, right? And then efficiency is defined as this over this. It's like the useful energy you get out divided by the total energy that gets put in into like whatever like this like the machine is, you know. Also called capitalism.
This I do remember from GCSE physics.
Yeah, this is cool. We assume the wattage is average since actual fridges cycle on or off. Yes, Jeff brings up a very good point. Yeah, fridges don't run continuously at this power. Otherwise, the fridge would try to get to like absolute zero eventually. Like it wouldn't, but it would just keep trying to cool it down, cooler and cooler. So yeah, fridges they're on for a little bit of time and then they turn off and they let a little bit of the cold leak. Or really, what they do is they let a little bit of the heat come in and then they turn on again. So
it's called a thermostat.
It's called a thermostat, which we could go into. There's some cool physics on like how thermostats work. They're basically resistors, right? Are they thermistors? Is that how they work? Is that how a thermostat works?
Thermistor, yeah.
I think it's a thermistor, yeah. It just measures, so resistance of an electrical thing changes with temperature, and you can calibrate that. Okay, but this one is not, nothing to do with efficiency. Okay. I do see how they say effective, cost effective. It kind of means like efficient-ish, but yeah, not really. Okay, what we want to do is we want to figure out the cost. Okay, so the cost of a fridge, okay, is going to equal the dollars per kilowatt hour times the number of kilowatt hour. Okay, so this is like total cost. Total cost is equal to like, I would say like the unit cost times the number of units you bought. Okay, you can think of this as like, say milk is like $5 a gallon, right? Let's say it's $5 per gallon, and then you multiply it by how many gallons you bought. Okay, and those would cancel. So this we know, and this is almost like stoichiometry. It's kind of cool. So this says 13.4 cents. So let's put that into dollars, right? That's just going to be $0.134. And then we say per 1 hour. That's when it says, sorry, we'll say per kilowatt hour. Sorry. Kilowatt hour. Okay. Now I need to multiply this, right? If I'm trying to get dollars at the top, right? I'm like question mark dollars is equal to dollars per kilowatt hour. Then I need to just multiply by how many kilowatt hours are here. Okay. So this is the thing we got to get, okay? So now, let's do another stoichiometry thing here. We're going to say, okay, cool. How many kilowatt hours is equal, right, to running a fridge for 5 years at 780 watts. So let's say this. Let's say 780 watts, okay? 780 watts for, I don't know. Well, we'll just say like 780 watts. Okay. Okay. So first of all, I need to convert this to kilowatts. So I'm going to say 1,000 watts is equal to 1 kilowatt. Okay. And then, so that's going to be kilowatts. And then I need to multiply by hours, right? So let's see what we're going to do here. Okay. Oh, it's 780 watts. I don't know. Let's say like per 5 years. No. What do I want to do? 780 watts per, let's say like the lifetime. Yeah, I know I want to times 5 years. I want to know how do I do it with stoichiometry though? What do I need to like set this equal to? Yeah, okay, whatever. We'll do it this way. Okay. I'm going to multiply by 5 years. Okay, but I want hours. Okay, so then my next thing is going to be that 1 year is the same thing as 365 days. Oh, total usage over 5 years. Ah. $365.24. Okay, well, whatever. Yeah, whatever. Yeah, he's right. Technically, he's right. Yeah, this is what we technically have to do. I have to technically say 365.24. Or, yeah, because this is where the leap year comes in, by the way, guys. Like, every 4 years, there's a leap year. It's because technically a day is an additional quarter. Okay, and then, right, 1 day is equal to 24 hours. Okay, so now, watts, years, days. We're going to be left with kilowatts times hours. Oh, the Gregorian calendar? That's where that comes from? Oh, that's kind of cool. Okay. Last step is to use some calculadora stuff. Let's hit that calculator. All right. Calculator coming up. So, we're going to do 780 divided by 1,000 times 5 times 365.24 times 24. Okay, cool. So that's going to get me, that's the total number of kilowatt hours for the 780. So for the 780, we're going to have, what is it, 34186.46. And then if we replace this with the 675, so all we really have to do here is divide this by 780, multiply by 675. You could go through and do all the math again. I'm just taking a shortcut. This is going to be equal to 29584, 29584.44. Okay, that's the amount of kilowatt hours, and then we're going to multiply by 0.134 to get the cost. So 0.0134 times. So let's get some dollar amounts here. So this one times 0.134. Oh, I typed that in wrong. Oh. Wow, that's a lot of money. Wait, that seems pretty fucking high. Really? Wow, okay. So that's 3964.31. Uh-oh. Dude, it costs $4,000 to run this refrigerator over 5 years. Maybe I don't want to buy refrigerated food at this point, dude. What? Excuse me? That's expensive. Okay. Multiply this by 0.134. And we get 4580.98. Okay, cool. So this one is very expensive, the 780. And even though it is $50 cheaper than the $700 fridge, that's not going to make up the difference. So what we end up saying is that this one, the 675, is a much better buy, is what we would say. Yeah, the 675. Let's see. Yeah, which I think is... Yeah, what do they get? They get 3945. Okay, yeah, we get about the same answers. Where is the break-even point, Dr. Gold? Probably a lot earlier. Probably like after the first week, to be honest. Yeah, if you wanted the break-even point, so, right, here, we'll say cost of the first fridge equals cost of the second fridge. First one is $650 plus, oh, well, here, let's just get what this is. If I just get this, then we can just change this as a variable, right? So, what is that? Oh, and wait, and this is actually a time, right? So it's going to be 365.224 times 24 divided by 1,000. You're easier to distract than the Canadian. Yeah, Penn Center locks in sometimes, dude. Anyways, this is 780 times 8.7. Well, it's a good question. Like, you know, when do they? And then this is times t, and then this is 650. This is 700 plus 675 times 8.77 t. So this is like the upfront cost of buying each fridge. This is the per year cost of running it, and then this is the watts, and then this is the number of years. Okay, so you can solve these two actually, if you wanted to. It's a good question, Jeff. I actually like it. It's good. Okay, so if I move this over here and this over here, but no, sorry, I move this over here. I move this over here. That's gonna get me. Oh, writing in different colors now. Sorry. Okay, that's gonna get me 780 minus 675 times 8.77 t is equal to 50. This is 105, right? Times 8.77. Let's do that. And then let's do 50 divided by that. So 0.05. Okay. Okay, times 365. Okay. So after 20 days is what we say. So after 20 days, the discount you got from buying the, what is it? The super cool fridge for $50 less, that $50 discount goes away after 20 days. So this is why it's important. You know, I know none of y'all are old enough to really be buying appliances.
No.
But when you do, it is important to look at what the power rating is for things. Because you can calculate long term that, like, hey, I may get the cheaper fridge now, but after a month, just from operating it would have made more sense to buy the more expensive, efficient one. If you want to know what these things look like, these little, here, it's called like Energy Star sticker. You guys may have seen these if you ever go like, I don't know, shopping with your parents at like Home Depot or some shit. Can I see an image, please? Yes. They'll do this. So I think they're required by the law, by the government requires them by law to put this on appliances. So this, for instance, is a dishwasher, and they'll tell you, look at this, you know, kilowatt hours, estimated energy cost, and then this is how much it should. So they do all the math for you. So you can look at this and be like, okay, cool. After a year, let's say this dishwasher costs $20. The other one costs like $50. How do I take into account like which one's cheaper in the long run? Anyways, does that make more sense, Ace? Ace, yeah? You got a bunch of work there. That looks pretty good. Yeah? Okay, cool. Good job, dude. Right, come here.
done! Well done!
180.
180 what?
The high scoring dance.
Let me see. I'll pull in Zero. Which one do you need help with? Do you need help with all these? I mean, it's okay if you do, because we just got equity afterwards. Oh, we have a bunch of questions. Oh, we got a lot of questions. Zero says yes. Okay. That's okay. Well, wait, is this? Oh, this is economics. Ooh, you're gonna bust my chops on this. Ace says, could you quickly explain conservation of energy? Yeah. The quick explanation for conservation of energy is that the total energy before and after has to be the same. And total energy can either come from potential, which is mgh, or kinetic, which is moving, that's 1/2 mv squared, or eventually you're going to learn about springs, and that's 1/2 kx squared. So there's a bunch of different sources of energy. What's up, Swaz? What's going on, my guy?
What's up, man?
How's the life, bro? How's it going?
It's going good. It's going good. I failed my physics test, so I'm gonna need to get some help on that later. But it's stat
Okay, you're
tonight.
good.
But you got some questions, so I'll let you go through those.
Yeah, you're good. Let me know when you got to run and whatnot, and I'll bump you up because like you haven't asked a question in a while. It's totally cool. Just like if you have like a
You're all good,
deadline where
man.
you're like, fuck, like I gotta go to dinner. Totally cool. But yeah, let's.
I
we'll
already
get you
ate
up.
dinner.
I already
your
ate
time,
dinner.
man.
Okay, cool. We'll take our time then. Nice. Okay, this is economics. Economics coming in the house, in the hizzy. Let's see. Wow, these are very high resolution images. Okay, let me kind of look what's going up. Yes, I always mess this up because economics to me is kind of, it's like counterintuitive, honestly, is how I kind of feel about it sometimes. You're like, wait, the curve should move this way, it should move that way. And nuclear annihilation, what? Okay. Don't look at it. I think it's wrong. It's okay. Okay, okay. Yeah, okay, okay, okay. And then we got this. Uh-huh. Okay, well, we don't need the dishwasher anymore. Okay, here we go. Let's try to do this. These are calculations. These are formulas usually. You just have to know. Okay. It says when the price of gas was $4 per gallon, one gas station sold 400 gallons in an hour. When the price rose to $4.50, they sold 380 gallons an hour. Calculate the price elasticity for the demand of gas. Show your work. Okay. Yeah, elasticity refers to how much does the price change based on the demand changing, or how much does the demand change based on the price? Like there's certain things that are price elastic, and there's certain things that are price inelastic. One thing that is like price inelastic is water, for instance. So if water gets more expensive, people are still gonna buy it. Doesn't matter. Gasoline is also pretty inelastic. Like we all need gas in order to like use our cars. So if they charge $10 a gallon, we're not gonna like stop using our cars. If I don't get all 38 questions correct in my algebra work thing, my final grade will be a C. Might be cooked. Got until Friday. You have to get 100. What position puts you in, Billy, that you need 100 to not get a C? What is unit elastic? Good. Unit elastic, I think means that for every change, unit usually means one. Unitary usually means. I think it means like whatever change in price creates a 1-to-1 change in the demand. I think. Yeah, sorry. Economics I haven't taught in a bit, and it's a lot of definitions. Yeah, exactly. Okay. Change in one variable is exactly proportional to change in another variable. Yeah, unitary elastic. Yeah, here. This is actually why is none of my clicking work here? What? If price went up by 12% and demand went up by 12%. Correct. Usually if price goes up by 12%, demand would go down by 12% though, right? Something gets more expensive, people demand it less. Unless it's, I don't know, like NFTs or some bullshit. Yeah. Who is this person teaching this? Anyways, okay, cool. All right, I see the equation. But you're right, because elasticity is the absolute value. So we don't care if it's positive or negative. We just care the magnitude of it, okay? Slides prepared by Iris Franz. Okay, that's cool, Iris. So, okay, so they want percentage change in quantity demanded divided by percentage change in price. You have the right equation here for percentage. So percentage change is always... oh, this is where this is a little bit wrong. Okay. So percent change is equal to final minus initial over initial. Here you have initial minus final over final or something. Yeah, you swapped it. It's okay. So yeah, so the final here is $4.50%. And first of all, yeah, you want change in price on the bottom. Oh, which you did do. Okay, sorry, you're correct there. Okay. So yeah, this is going to be 4.5 minus 4. And it's not over 4.25. It's over the original. It's over the original 4. He said it was like the final over the average. Really? It's kind of bullshit. I don't think it's over the average. Oh, you're right, but they do the average here. Okay. Yeah, they use the it's called the midpoint method. Okay. I'm just, yeah, okay, you're right, Zero. In science, not economics, it's final minus initial over initial. They're doing final minus initial over the average. Okay, that's fine. Yeah, no, it's okay. No, you're correct. I mean, I just haven't seen this in a bit. But yeah, okay. It's divided by the average. Fine. So, yeah, that's over 4.25. And then this is over... this is going to be... What is that? 380 minus 400 over 390. Yeah, so just swap them. So then you can get some numbers, right? So let's see. What do we got? So that's 0.5 over 4.25. Cool. And then divided by... it's absolute value, so I'm just going to say 20. I know it's negative 20. Divided by 390. Okay. So that's 2.29. So that is very elastic. Okay? I would say it's elastic. Because, yeah, this got me 2.29. Yeah. Okay. Yeah, demand on top and price on bottom. I mean, Iris Franz could be wrong. I don't think she's wrong, though. Did I do something wrong, Jeff? I don't think I did. Wait. A 12.5% change in price, but only 5% change in demand. Oh, I did the wrong thing, too. I flipped it again. No, price should be on the bottom. I screwed up. Sorry. I screwed this up. Yeah, no, you're right. It's demand. No. Yeah, thank you. Thank you, Jeff. Jeff gets a save. I was doing this part. Yeah. Okay. Yeah. Jeff is right. My bad. I mess up sometimes. It's okay. It's my first time doing economics this year. I think this is called microeconomics too, technically, right? Yes. Yeah. Okay, cool. All right. So flip it. Yeah, flip it for me. So whatever. You just say this to the -1. And that's going to get you 0.44. Okay, so inelastic is correct. I was wrong. So whatever. Flip it to the -1. 0.44. Okay, cool. When the price of toothpaste increases by 4%, the quantity supplied increases by 14%. What is the numerical value of the price elasticity? I think it's the same thing, right? It's just 0.14 over 4. 0.14 over 0.04, right? So 0.14 divided by 0.04. That's going to get us 3.5, which I believe is elastic. Yeah. What is perfectly elastic? Is it like infinite? Right? Or is there a number that's like, what is perfectly... No. That's unitary elastic. Yeah. Yeah, I guess perfectly elastic is like close to infinity. Okay. This is not close to infinity. This is only 3.5. So I think it's just elastic. Okay, when the price decreases by 6%, the quantity demanded decreases by 0.12. Okay. What is the numerical value? Yeah, it doesn't change, right? So the number should be infinite then, right? Yeah, perfectly inelastic is if it's 0. Right. Yeah, then perfectly... Wait. Yeah, perfectly inelastic is when it's 0. Perfectly elastic is when it's infinite. Yeah, okay. Okay, when a price of a good increases by 6%, the quantity demanded decreases by that. What numerical value of the cross price elasticity? What is cross price elasticity? Oh, it's the same thing? Oh, what would you say is a bigger debasement of mathematics, engineering, or economics? Probably economics. Okay. Oh, cross price. It's talking about two different products. Oh, okay. Oh, I see why it's called. Okay, yeah, Zero. This is called cross price because we're talking about the price of good A compared with the demand of good B. They're two different goods, but I believe it's the same thing. It's just demand over price. So it's just 0.12 over 0.06, which is going to be equal to 2. Okay. Based on your answer in part A, what can you say about the relationship between goods A and B? Okay. There's always like some table. Yeah, this is one. Cross price elasticity determination. Here we go. I can always find it somehow. Yeah. Economics is just a bunch of terminology slapped on math stuff. That's what Jeff's talking about, it being a debasement. Zero. Okay, so here it is. So if cross price elasticity is, oh, and then let's make sure one of these is negative, right? So this increase, this was positive, this decreased, right? So this is technically -2. So we say that if the cross price elasticity is negative, then the two are complements. Okay? Yeah. With an E. Yeah. Compliments with an I, sensational get you, is like words of praise. Compliments with an E means they match. Yeah, Crit, I can always help with physics. Yeah, you're good, dude. Yes. Did you submit a screenshot, Critical? I'll do it. Yeah, so these are complements. which means like they're necessary for each other. So some examples of like complement goods would be like cereal and milk, right? You can't really eat cereal without milk unless you're like an absolute savage. Whereas substitutes would be like hot dogs and hamburgers. So you can kind of switch them out. Yeah. And then independent, that would be like dish soap and bananas. Those things are unrelated. Like you don't like bananas don't replace dish soap, and they don't really go well together. I don't know. I've never eaten a banana and dish soap. Don't do it. So yeah, okay. Yeah, that's cross price. And I mean, this kind of makes sense, right? So because good A is going up in price, people aren't going to demand good A as much, right? Let's say the price of milk starts going up, right? You're not going to want to buy milk as much. And because you're not going to want to buy milk as much, now you're not going to want to buy cereal as much because you don't have milk. Like, why would you buy cereal without milk? Submitted one. Hi, what's up, Haunted? I'm on my own for a bit. Uh-oh. Okay, cool. All right. Let me see if I can help you. Let me help you with like one or two more. Zero. Let me help some other students, and then when I got time, I'll come back and do the rest of your economics because I like this stuff. Is fun. I enjoy this. Let me see like this one. Here, I'll try number 4, and then if I have time, I'll do like 5 and 6. You'll go eat. Yeah, awesome. Yeah, great. I'll be on for a bit. I don't have to teach other students till another 2.5 hours, so I got time. What's up, 1K? Okay. When income increases by 10%, the quantity demanded of good X increases by 5%. What is the numerical value of income elasticity? Oh, that's kind of cool. So I think that's 0.05 over 0.1, which should be 1/2. Okay. And it said, based on A, which of the following classifications accurately describes good X? Is it inferior? Is it normal, necessity, or luxury? Ooh, interesting. Kind of cool. I'm gonna go off of a bat here and think that it's I think it's a normal good, maybe, and I'll explain why before I like look it up. So I believe if yeah, well, let's think about this. So income, this is like money coming in, right? Think about like during COVID when the government just started handing out $1,000 all the time. What did people start buying? They started buying like crypto, I don't know, like a new skateboard. People bought laptops. I bought a lot of streaming equipment and gift cards for you kids. That's what I bought with all that COVID money. So when you're given more money, you tend to spend it on things that are not really necessary, right? It's like you got extra spending money. So luxury. So I would say if when income increases, the demand for something spikes a lot, then that must be a luxury good. I would think that if the income increases and the demand does not change, then that must be a necessity, right? So necessity means you're going to buy that and have demand for that no matter what amount of extra money you have. Like say, for instance, toilet paper, right? If you make more money, you're not going to demand more toilet paper. You're not like taking a shit more often. I don't think so. I mean, unless like you're buying like food that does that, I guess. So yeah, if price elasticity is 0 there, I would say that. If price elasticity is negative, I would say that's an inferior good. Okay, so that means when you have more money, you start buying less of it. So an example of this would be, let's say, like shitty food, like cheap shitty food, like ramen. Ramen is probably an example of an inferior good. When you're given more money, you're not going to spend that money on ramen because that to you is not nutritious or really good for you. It's cheap, which is great. Like I've eaten plenty of ramen. I love ramen. But if you're given more money, you're not going to spend money on inferior goods because you can spend them on normal goods or luxury goods. So I think this is probably a normal good. My teacher said something about being between -1, 0, and 1. I agree. So yeah, let's look at that. So what is this? Income elasticity. Yeah, you're right, Haunted. Like, economics is tedious, but it's pretty cool because it takes human behavior for buying things and like how we work, and it puts numbers on things. Like it uses math to like describe behavior. I think that's really cool. Let me see. Inferior, good. Luxury, good. Yeah, they just say necessity, inferior. Oh, and it has to do with the elasticity of it. Oh, that's kind of cool. So watch this. Very cool. Right. So if it's less than 1, if the magnitude, so let's say like magnitude of, what is it, of elasticity is less than 1, that means it's inelastic, right? I think that's what we said earlier here, right? Is that what we said? Yeah. If it's less than 1, it's inelastic. Okay, if it's greater than 1, it's elastic. If it's 1, it's unitary elastic. We don't really care about that. So if it's less than 1, it's inelastic. And then if it's positive, that means it's a normal good. Okay, cool. So yeah, so this is 0, right? It's inelastic and it's positive. Cool, right? If it was inelastic and it was negative, okay, like we were talking about with the ramen, right? That's an inferior good. If it's elastic and it's positive, that's a normal good. Okay, you have more money, you're going to buy more stuff. That's cool. And then I think luxury is elastic and like really positive. Yeah. I think it's like super elastic. Anyways, cool. All right, let me help out some other students. Zero, I appreciate it. These are cool questions. And I'll come back and help you out with the other ones. Well, okay, it says, Dr. Gold, can you do my question after this? I got to go to work in 25 minutes. Maybe. Let me see. I do have a lot of new people that asked, that haven't asked before, and they asked before you. Steph has one. D is a lot of work, and I got stuck. Calc and V. Getting V by itself. Okay. Oh, I know this one, Steph. Yeah, this is... Oh, you'll be back, Zero? Okay, awesome. Great. Wait, did I give you your bond coin? Should have gone through. Okay. Let me see. Let me see what all the questions we have. Lost and Saga's got one, too. Haunted, are you Steph? Haunted, who are you in my Discord? Which person are you? Which person are you, Haunted? You're Steph? Okay, cool. Here, I'll help you out with this one. Part D is use a differential equation. Uh-oh. They're making you use differential equations on Physics C? Excuse me? That's kind of rude. Okay, let's see. A box of mass M is initially acted upon by a constant force applied by Fa as shown. The friction between the box is going to be negligible, but the box is subject to a drag force of force kV. Okay, cool. And K is a positive constant. Express all the forces. Okay, let's do it. It's not too hard, right? So we got Fa pulling this way, right? We have Fn. We have mg. And then we have this drag force, which, what are they calling it? Oh, we're not calling it fucking anything. All right, fine, whatever. FD. Okay, cool. All right. Right, but do not solve a differential equation that we can use to determine the speed of the blocks as a function of time. You do not need to draw anything. Do not add anything. Okay, cool. Well, let's think about this. Okay. So if we look at the sum of the forces, right, in the x direction, you have the force A, which is pulling it to the right, minus the drag force, which is pulling it to the left, okay? And then this is equal to the mass times the acceleration, okay? Now, okay, as a function of time, V is the speed of the box and KV. Okay. So here, let's do some stuff here. So, do not add anything to the figure. Okay, fine. All right. So FA minus, and then this is going to be the drag force, which is KV, is equal to M, and then acceleration here is dv dt. Right? So we got to make a differential equation out of this. Yeah, that's okay. You want to get all the variables on one side is what you want to do. So I want anything with V to be next to V and anything not to be somewhere else. How do you do this, though? FA minus KV is M dv dt. I don't want the dt attached to that, though. Oh, it's not separable. Oh, okay, that's fine. All right, whatever. Okay, so M dv dt plus KV minus FA is equal to 0. So, yeah, this could be used. Okay, cool. I think this is all you need. Do you have the solutions to these, Steph, by the way? You know you can... They have solutions to all these. Yeah, this is a 2013. Yeah, they have answers to these. You multiply by dt. I mean, yeah, the issue is that I don't want dt to mess with v. Because then I also have a dv here. Just in terms of, like, solving differential equations, you don't want to mix the variables. I think what we're going to end up using is there's some, like, e to the ix. Oh, divided by m. Oh, yeah, that's totally cool. Yeah, oh, yeah. And actually, that is standard. I should have done that. Right, okay, so dv dt plus k over m v minus fa over m is equal to 0. I agree with that. That's okay. Determine the magnitude of the terminal velocity of the box. Okay, cool. That's just when the applied force equals the drag force, right? So fa equals fd. Because when that happens, your acceleration goes to 0. So I just say fa is equal to, what was it, is equal to kv. So v equals fa over k. Is that all they want? It's kind of silly. Okay, and then use a differential equation from part B to derive the equation for the speed as a function of t. Assume v equals 0 at t equals 0. Okay. To do this, yeah, this is a differential equation. Which are you so usually when solving differential equations, Haunted, we just assume a solution and then we check to see whether we're right or not. I wonder if that's what they want you to do. Or I don't know if there's if it was just this, like if we had this away, if this was gone, I could solve this pretty easily. That's what would be called a homogeneous differential equation. Because then I can just move the dt on one side, move the let's say this was gone, just so I can show you how it works. So here you have dv dt plus k over m v is equal to 0. And then you just move things over. So you get dv dt is equal to negative k over m v. You can move the dt up here. You can move the v down here. And that's dv over v is equal to negative k over m dt. And then you could just integrate both sides. And then this just becomes ln of v plus c is equal to negative kt over m. And then you have to use the initial conditions to solve for what c is. That's how to solve the homogeneous form of this. Homogeneous means, like, instead of having all of this equal to this on this side, I just have it equal to 0. But that's not how the world works with this question. That's really mean if they're asking you to, like, solve differential equations here. Let me think. I use time and not v of t for that part. How did you use time? Are you saying for part C? Why don't you use 0 equals a, b equals v of a t for the integral? Oh, sorry. Yeah, let me see. Oh, yeah, let me see. You did post screenshots of what you're doing. Ooh, let me see. Yeah, let me see what you're doing here. I think there's got to be some math wrong here. Yeah, let's see. Let's see. So, okay, I agree. So you moved this all over here. Okay, cool. You divided both sides by FA minus KV. Yeah, maybe I'm dumb. I could be dumb. That's okay. FA minus KV. Oh, yeah, actually, you know, that okay. Yeah, you're okay. Yeah, you're right. Right. I like the way you're doing it. Yeah, okay. This is actually, yeah, this isn't that bad. Okay. Yeah, here, let's take this. I thought it wasn't separable for a second, but it is. So yeah, dv dt is equal to FA over M minus K over M times V. Cool, yeah, and then I guess you can pull the 1 out of 1 over M over, I guess, right? Is that what you're doing? Yeah, we can pull the 1 over M out, right? Let's just do that. Okay. And then you're going to put this on the bottom, and you're going to put this on the top. Your integration is probably just the only thing that's lacking. Okay, so then dv over FA minus KV is equal to 1 over M dt, right? So now we're going to integrate this. Integrate both sides. This is easy. This just becomes 1 over M times T. This is a little trickier. If I say U is equal to FA minus KV, then DU is equal to negative K dV. Okay, so you just need a negative 1 over K. So then this is ln of FA minus KV all times negative 1 over K, right? We're going to do the bounds. Yeah, I'm going to show you how the bounds work. Because what I'm going to do is I'm just going to say like plus C. This becomes, you can do things without bounds, and then just we're going to figure out what C is. Because I have negative 1 over K ln of FA minus KV. Yeah, watch. 1 over MT plus C. And then here's what I'm going to say, which is that V equals 0 at T equals 0. Okay. So I can say V equals 0 when T equals 0, right? So if this goes away, right, and then this also goes away, that tells me that C is equal to negative 1 over k ln of fa, right? I think that's right. Okay, cool. So now I have negative 1 over k, and here we can take this c now and put it over. So this is negative 1 over k. And then this is ln of fa minus kv minus ln of fa is all equal to t over m. And then these will combine. So let me move this over here, right? So let's get rid of this and make this a negative kt over m. And then I can combine these with logarithm rules. So this is ln of fa minus kv all over fa, right? Is equal to negative kt over m. E to the. I get fa minus kv all over fa is equal to e to the negative kt over m. Multiply both sides by fa, and then do a little bit of algebra stuff, right? So then this is fa e to the negative kt over m minus fa is equal to negative kv. So then flip and whatever, right? So v equals fa over k, or fa 1 minus k. Oh, no. No, I'm getting too fancy. fa over k 1 minus e to the negative kt over m. And let's see if that makes sense, right? Is that correct there? I think that's correct. Is that correct, Haunted? That was so much more detailed than the AP answers. Yeah, well, they're not going to give you the most detailed explanation for how to do it. Yeah, I know. Well, the key thing here, yeah, so you were asking, like, do I have to put bounds here? Because, yeah, usually this would be, like, v0, and then we would say that this is at, like, v at time t, and then this is t equals 0, and this is, like, t at, like, t equals t. You can do this, but I find that to get, like, kind of messy. So what I like to do is just slam a plus c on it. Do it as an indefinite integral. You linked on your Discord post? Cool. Oh, it won't let you post links there. Can you post it in office hours? Here. Here. Yeah, that should be able to do it. Yeah, so yeah, the help screenshots channel only lets you post screenshots. Because otherwise it would get really messy. What? Oh, I have to give you the link. One sec. I have to. You're new to the server, so I have to give you the can post links. Okay. Now you can post it. Yeah, we have that protection because yeah, thank you. Yeah. Because we're a public server, I get a lot of spam from like people trying to sell feet pics or something. No feet pics here, please.
Give us spam from me.
Spam from me? Yeah. Are you gonna spam us with feet pics?
Well, I keep spamming that server with random shit.
Oh, I love these. These memes are great. How to make a bomb 101, forcing him to listen to all of this. So good. Wait, where was this question?
8 terabytes of mayonnaise slapping noise.
Oh, that was the wrong question. Okay, yeah, let me pull up the right one. Oh, okay, here we go. Yeah. Okay, cool. We get the same answer. Yeah, nice. Yeah, they put the bounds on it. That's fine. You can if you want. I don't know. I feel like I'm like, you know, we'll settle this in the streets later. Like, just put plus C and then figure it out. Also, you should also, just as a quick thing, Haunted, when you get your answer, this is what I was wanting to look at. You want to look if this makes sense, okay? So what I always like to check is, like, as t goes to infinity, what happens to v, right? So as t goes to infinity, this becomes e to the negative infinity, which is the same thing as 1 over e, which eventually just becomes 0, right? So eventually this goes to 0, and velocity goes to fa over k, which we should have seen here. Do you see how, like, for instance, this is where it's all connected there, Haunted. Terminal velocity, right? So terminal velocity means velocity after a very long time, was also fa over k. So this is where you can check the math afterwards to see if your answer makes sense. And you can see, for instance, when e is equal to 0, sorry, when t is equal to 0, right? E to the 0 is 1. V equals 0. So both of your conditions are satisfied, which helps you know that, like, I got the correct answer, right? Cool. That was a really fun one. I really like that one, Steven, actually. That's a good question. Yeah, the calculus is hard for you. I understand that. Yeah, it's annoying sometimes. And, bro, like, you know, I got tripped up here. I didn't think this was solvable. I was like, nope. Like, how do you do this? Right? Stephanie. Okay, cool. Stephanie.
What
Oh, we have another girl?
is this piece of
Wow, we got another girl on the server? Hell yeah, dude. Sorry, I don't know if you heard earlier. I was going through my YouTube analytics, and it says that, like, 85% of my viewers are guys. And I'm just like, okay. Like, what do I need to do to make my stuff, like, I don't know, more watchable for girls? So I'm glad you came and found help. Awesome. Oh, that's what the Steph XNSS is. Steph fans. Okay, I got you. I just thought it was Steven. Okay, cool. Does that make sense, Stephanie? Does that help you out?
Can you hear me?
Yeah, one sec, Ethan. One sec, Ethan. Yeah, okay. Yes. You're very welcome. Feel free to come by with any physics questions and stuff you need. I'll also say, like, since you're in AP Physics C, I run a review session usually in the spring. So I don't know if I told you that already, but yeah, hang around, and in the spring I'll end up doing a big thing for all the AP Physics students. So I do like an AP Physics 1 review, and then I do AP Physics C. I just do like a walkthrough of the exam. It's pretty cool. For E&M too, yes, I do both. Yeah, mechanics and E&M. I don't like that. I think AP Physics 2 does, like, waves and stuff. I really don't like. I don't like the waves and sounds and optics stuff. That's, like, kind of weird. But yeah. What's up, Ethan? What do you want to say? What's going on?
Well, you know, I was just thinking about something.
What were you thinking about?
So listen to me very carefully here, because
Listen to you very carefully too. Serious? What's up?
So when I was coming home from school, I got on a bus and I went to home. But an hour later, I have this one friend that I talked to who said that she's going to participate in this supposed 500-word essay about the importance of youth being involved in governance. And
I
that got me
believe,
thinking to myself,
youth should be
hold on,
involved in
I'm not
government for
even
sure.
done yet. Yeah, but let me finish. And that got me thinking to myself if I should actually participate in this essay. But the one thing that I do not like is the fact that if I come in first place, then I'll be the mayor for like one day.
What is the mayor? What do you mean? You're the mayor of your school? That's pretty cool.
Not school. I honestly do not know how far that goes, but I think the country of Belize.
Oh, that's cool. The country. That's cool, man.
scared because I don't want to like redirect my country into poverty. Then I
Well,
want to make stupid decisions.
yeah, it's okay. You're young, man. Don't worry about that. And like, also, that's why you have a team of people around you, who help you make good decisions. You know.
Well, yeah. I wanted to ask you, should I really try it? Should I really participate in
Yeah, go
that?
for it, dude. Yeah, go for it. I always say go for things.
For
You
real?
miss 100% of the shots you don't take. You know. So take them, dude.
What?
You miss
Oh,
100% of the shots you don't take. Like if you don't try, you're gonna miss it for sure.
all right.
Is that
Well,
Michael Scott?
look,
You
the
Michael
thing that the
Scott?
thing that
Yes, it is Michael Scott. No, it's Wayne
I
Gretzky,
knew it.
right?
I knew
Is
it.
it Wayne Gretzky, dog? Michael Scott. Taco Cat says, "May I
what
go
about the
next?" I got a log. One sec. I got a queue of people. Equity's next. Equity is next in the queue. If you want to go first, you gotta put your questions in first. Or I think there's a thing you can buy that says "me first." I think there's literally there is there's a channel point thing. What's up, Ethan? Yeah. What's up? What's up? So
yeah, yes. The thing is, my English grade really isn't supporting that idea because I have a literal C plus in it, and I do not know if I want to do this essay.
well, you can take an attempt at it, and then you could like send it to me, and I could like tell you whether it's good or bad, or like how to make it easier, or make it better. You know?
Oh, for real?
Yeah, for real, dude. For real.
All right then.
Okay,
Good
cool.
with essays?
What's up?
Are you good with essays?
Yeah, I was helping someone out for 3 hours last night on a bunch of essays they were applying for pharmacy jobs. Yeah. Yeah. I'm pretty good with essays.
All right.
Yeah.
Then.
Cool.
I got a math question. So
I see
I'll
yours.
just wait over here.
Nice. Yeah, you're good. Yeah. Equity, is Equity here? What's up, Equity? Taco says I was out with my friends. Yeah, that's okay. Okay, if Equity's not here, Zero's not here. Swaz, you're next. Come to the plate, Swaz. What are we doing? We're doing stats?
Yeah, we're doing stats. Shoot, I was
Okay.
like finishing up some of the other problems I had before it,
Okay, what's up?
but I should have sent like I sent like a little thing to you.
You said
Yeah, I got a game in the background. Let me turn it down because I can't hear
Okay.
you.
You're okay. You're okay.
Yeah.
Yeah.
All right. So I'm doing 43 through 53 odds.
Okay. In this this big thing you sent me here.
Yeah, that big thing.
Okay.
Yes. So it's just like, just stats.
Okay. All right, you just want to run through them? We'll run through as many.
Yeah,
Well,
just
okay.
can we just run through them real quick?
Yeah, we can run through them. That's cool. Yeah, because I think they're just like easy word problems.
I'm pretty sure they are. Yeah.
Okay, here. Let's see. All right. This one. Good for the gut. Is fish good for the gut? Researchers tracked 22,000 male physicians for 22 years. Those reported eating seafood of any kind at least 5 times had a 40% lower risk of colon cancer than those that ate seafood less. Explain how confounding makes it unreasonable to conclude that eating seafood causes a reduction in the risk of colon cancer based on the study. Oh, that's cool.
Well, okay. So another thing I'm like confused on, a lot of the terms
Yeah.
that we're using right now, I'm just kind of like confused on them. So like, what is like confounding?
Confounding
does that mean?
means, confounding means that it could be caused by multiple things. So, for instance, if I want to look at like how kids are doing on their tests, like, and I want to say that kids who eat this very expensive type of granola will do better on their tests, and then I see that kids that do eat that very expensive granola do better on their test. There are other variables at play here that could be affecting them doing better on a test. And it's not the granola. It's because if you eat this very expensive granola, then you must be able to afford very expensive granola, which means you must have money in order to pay for like tutors or like any other thing to make sure you get good grades on tests. So it's not the granola, right? The confounding variable is like income status.
Yeah. I understand that. So in this case, it would be like, would a good answer for this be like, there's like other factors that could play into like.
Yeah, you want to give examples. And so
Colon
Jeff,
cancer.
yeah, Jeff brought in a good one here where he says that people who eat more seafood may live closer to the ocean, which might have a higher humidity. Right. So they're saying that like, oh, if you eat seafood, you have a 40% lower risk of colon cancer, but it's like, whoa. You have to take into account those people that eat seafood. Do they eat more seafood because maybe they are richer? Seafood's not cheap, right? Seafood's expensive.
Yeah, true.
So if you can afford to eat seafood 5 times per week, you probably got a lot of cash, which means you're probably able to take care of your health better, right?
Yeah, I see
So-
what you're saying there.
So that's one way you can say that. That's a confounding variable. Yeah.
Let me just write that down. So like people who can afford to eat seafood, like they're probably like
Yeah,
more
probably
rich,
richer.
thus-
They're probably richer, and they probably have better access to quality healthcare or something. Yeah, that's what I would say. 94, blah blah blah. 20 minutes of Hollywood. The Island. Oh, I like The Island. 20 minutes
What's
of the
The
movie
Island?
with. It's just a film.
Oh wait, no, I know the island. I know the island. Or no, I'm thinking of Lost. I'm thinking of Lost.
You're thinking of Lost. 94 cringe, small sample size. It's better than 20, right? 25. Watching the same 20-minute of the movie with no sound and watching 20 minutes of an interview while watching, they were given different snacks and allowed to eat as much as they wanted. Dude, I want to be a part of this fucking study. This sounds great, dude.
That's dope.
Subjects who watched the highly stimulating ate more calories than those who watched Charlie Rose. The people who watched the silent version ate 46 more calories than those who watched Charlie Rose. So no one really likes Charlie Rose. Okay. Identify the explanatory and response variables, then determine is it an experiment or observational study. Okay, cool. So what are the two variables again? It's the independent and the explanatory. Is that what it is?
The response.
Explanatory and response. Okay, cool. That's what I'm looking for. Okay. So the response variable is like what they're measuring. So in this case, the thing they're measuring, right, is the amount of calories that these people eat,
Yeah,
right?
so
That's
like
the
calorie
response.
intake. Yeah.
Explanatory is like what is causing that change? What is causing the change in the calories?
The boring movie.
The boring movie, right? It's the type of movie they're watching.
Calorie.
Who watched?
And that's really all you have to do for that one, right? It's just say like response.
Yeah, so the response variable is the number of calories. It's just there's so many things here going on. Silent version of The Island, 46 more percent than the who watched Charlie Rose. So actually, no, the explanatory variable is whether they watched The Island with sound or watched The Island without sound. Okay?
So movie
'Cause-
type, or
You can say whether there was sound or not sound in the movie because
Okay.
because they both watch, right? They both watch Charlie Rose, and then one group also watches it with sound and one without sound. They say, is this an experimental or observational study? I feel like it's observational because they're not taking the same participant, having them watch Charlie Rose and then having them watch the silent movie and then having them watch the not silent movie. So they're just observing what happens. Experiments require what's called experimental design, which is testing something and making sure that there's a control group and that subjects are put through things, the correct way.
okay.
Yeah.
So it's really just based off whether they have a control group or not, as well as I'm sure other things.
It's just not designed correctly. That's why I think it's observational is just seeing what happened versus experimental is directly testing something. It's like taking your population and splitting them into things and having them do it correctly. So I would say it's observational because there isn't any experimental design to the groups going through, and there's no control group. Yeah. Well, I guess it's just like they're not using the same subjects. That's the problem. I feel like you have to use the same subjects watching Charlie Rose and also watching The Island. Otherwise, it's just an observation. Yeah.
All right.
Okay.
Yeah.
40, 47. Well, no, you could have 2 separate groups. Yeah, but I feel like that would still be experimental. Yeah, but I feel like the groups, Jeff, need to go through both treatments, right? Like there has to be a control. You don't think so? Okay. Jeff thinks it may be experimental. Like most things in stats, it's kind of up in the air.
I'll argue my teacher about it. I'll argue to him. I'll be like, well, this is why, you know.
Yeah, the control.
I'll make sure I
group
get the credit.
Yeah. Okay. All right. 47. Childcare and aggression. Okay. The more time children spent in childcare, the more adults tended to rate them? Like
What?
Phrasing, bro. What's going on here, dude? Okay. Follow them through their 6-year school. Later, the researchers published an article that stated the more time children spent in daycare, as less likely to get along with others, as more assertive, as disobedient and aggressive. Interesting. Okay. So the response variable here, right, is their aggressive rating, I guess, right? We're measuring what their aggressive rating is.
Okay.
It's kind of a weird thing. And the explanatory variable is whether they went to daycare or not. This is 100% an observational study because you're not splitting the group. You're just watching what happens to the group. Okay, so I'll take that back on the previous one. I will say you can say the other one before is experimental because you can say that they're at least setting up control groups and there's experimental design to it. This is observational because they just took kids and they just watched them and then they just saw what happened later. They didn't like say these kids are going to daycare. These kids are not going to daycare. Now we're going to see what happens. Yeah, exactly. So okay. Jeff says, yeah, in this case, you're not forcing one set of kids to go to daycare. Yeah, exactly. So, yeah, the one before, yeah, I'll take back my answer. I say that is experimental because you are setting up groups. I don't think it's a good experimental design, but you are doing it. So, whatever. It's technically experimental. Does this study show that childcare makes children more aggressive? No. Yeah, I don't know.
Is there any really, like, is there, like, any reasoning to it really at all?
Well, you can say that, you know, that while they're, okay, this is stats is all about language. Okay, you can say technically there is a correlation, okay? But you can say that this correlation does not imply causation.
Okay, yeah.
It's okay for there to be trends. You know, again, with the granola, right? I can say that people that eat expensive granola do better on their tests. That's cool. There's a correlation. But it does not mean that the granola causes them to do better on their test. It's just that they have rich-ass parents that can buy the granola. So that's why they do better on the tests. Yeah.
Okay.
Yeah, kids
That
who
makes
spent
sense.
more time in childcare are more likely to have parents who spend less time with them. Yeah, so it's not the daycare causing these kids to whatever. It's the confounding variables. All right, 49.
Yeah, the growing in the shade.
The ability to grow in the shade may help pine trees. How well? Okay. Full light. Okay, cool. All right. They dried the young trees and weighed them. Identify the experimental units and the treatments. I think experimental units are the different groups you're treating. No, the experimental units are the trees. This is all the terminology bullshit. What's experimental?
Yeah, no, I'm pretty sure it's just like the trees. I'm pretty sure it's just like when it says units, it's just talking about the trees.
Nice.
Yeah, okay. So in this case, oh, thanks for the follow. Freedom Dow. Yeah, you can ask questions here. That's cool, man. If you got, like, homework questions you want to help with, post them in our Discord. That's what students are doing here. They drop screenshots and they go,
Do you like the Google AI?
I'm just using because it's convenient. I like ChatGPT better. Cloud is the
That
best
thing
for writing
rocks.
code. Yeah, I use ChatGPT all the time. It's just
You ever
easy
tried
for me to
Claude?
Google. Yeah, Claude is good. Claude is very good for coding. What's up,
I like
Bosnian?
Claude.
Yeah, Claude's great. But I don't want to pay
Alright,
for
I
all of
won't.
them. There's so many of them.
Yeah, no, I'll take the free ChatGPT, man.
Yeah. Meta is actually one of the best ones that's free because it runs off of Llama 3. It's actually a really good AI algorithm.
I haven't tried it.
Okay. Yeah, it's the one if you open up Instagram or something, you can literally just like use it for free. And it's
Oh, shit.
it's almost as good as ChatGPT, I'd say. Whereas like for the Google for Gemini, you technically have to pay for that if you want the real one.
I haven't tried Gemini either. Yeah.
Yeah. The treatments is then just all the different lights, right? 5%, 25%, whatever, full light. Yeah. Cool. Freedom says, I built a lot of AI using Llama 2. It's very powerful. Yeah, Llama 3 is great. Yeah, what do you use, Freedom? You use a bunch of, I think like 3090s are the thing to use these days. Because there's different sizes of Llama 3, right? There's like the 80 gig or the 120 gig or something. I have a couple friends that look into building LLM rigs. 51, how can we reduce the rate of refusals in telephone surveys? Blah, 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 blah. Okay, whatever. Okay. Oh my god. Okay, one study made telephone calls to randomly selected households, asked opinions about the next election. Okay, cool. Did or did not offer to send a copy of the final surveys. Okay. So factors are like all the different treatments they're having. So you could say like gave her name, yes or no. That's a level. That's 2 levels, right? Identified the university, yes or no, right? That's 2 levels. Sorry. Identifying herself is the factor, and there are 3 levels to it. So she either gives her name, she gives the university, or she gives her name and the university. Do you see that? It's like the variable, then the amount of choices.
Wait, so what are the levels?
Levels is like, so factor is like, what is the thing I'm testing? Like, what am I varying? And then levels is like how many different choices you have to that factor.
Okay, so she like gave her name. That was one.
Well, yeah, so the factor is how she introduces herself. So that's the factor. And so the levels are gives her name, level 1, identifies university, level 2, or identifies herself and the university, which is the 3rd level, level 3. Let me see.
Okay.
Okay, and then there's offering to send a copy of the final survey results, and that's another factor. And there's only 2 levels, yes or no. Someone did something during Helene. Just old compute from 10 years ago. I built a road scanner and a road scanner with quantum mechanics saved my life during Helene. Wait, explain to me, Freedom Doubt. What? How did a road scanner, like to scan which roads are like not like screwed from the hurricane? Quad core 16 gigs. Oh, it's an i5. Oh, CPU. Oh, but CPU is terrible, dude. No, you want to go up to GPU. If you're doing anything with AI and stuff, GPU is like orders of magnitude better than CPU. For deployment, one I use during Azure. Yeah, I have an Azure data center I use. And they have A100s, which are ridiculously expensive. Oh, it was scanning the... Oh, that's super cool. One sec. I want to pull up like what an A100 price. A100s are expensive. If anyone wants to know like what's a very expensive graphics card, this graphics card is $8,000. And
What's
then
the benefit of it?
It has a lot of memory. It's got 40 gigs of memory, which is very useful for calculating AI stuff. There's a more expensive one, Freedom, dude. There's one that's like $30K. What is it though, dude? No. Where's the big price? Can it run at Fortnite at 100? No. So these actually are not very good at gaming. Because they what is the one called though? You know what I'm talking? There's like a really expensive expensive. I think it's called the H100 GPU. Is that what it is? Oh, here we go. Yeah, who wants to buy this, dude? Look. $25,000. Free delivery.
That'd be free delivery, bro.
I like the color though, dude. It's fucking dope. Yeah, it's not meant for games. It's slower than 4090. For AI, it's faster than 4090. Yeah, but the 3090 I think is the sweet spot. If you're actually trying to build a rig, getting used 3090s for like under $1,000 freedom are like the best way to build an AI rig. Yeah, that's what I would say. But that's cool. You developed some code there. That's nice. Do you think Alphabet is a good stock to buy? Yeah, Google's pretty cool. I think Google's good. If the researchers used every possible combination, how many treatments are there? Do you know how to do this? This is math.
Okay, so I was literally thinking about this. Would it just be super simple since there's like 3 levels and there's 2 levels for the other one? Would it just be 3 times 2?
Yes, it's just 6. Yeah.
Okay, that's what I thought.
Yeah, it's like you split it out to 3, and then each one of those 3 splits out to 2, so there's 6 total. Yeah. With ones you don't need GPU, you can just use CPU. Yeah, okay. I just know like the performance is a lot better, especially on Llama 3. Oh, I see what you're talking about, Freedom. Yeah. If you're doing like some low-level stuff, yeah. I know people talk about like, there's some metric, it's like token thing or something. It's like, or how fast it can like get to the next step. I looked at it briefly. Want a snack? Can snacking on fruit? Researchers randomly assigned 12 women to eat 65 calories of berries or 65 calories of candy. 2 hours later, all 12 were given unlimited amount of pasta? Bro, where are these studies? I want to be a part of these studies. You're just given candy and unlimited amount of pasta? The women who ate the berries consumed 133 calories, fewer calories. Identify the explanatory and the response variables. Do you know how to do this?
Can I answer this one?
Yes, I want you to answer this one. You go for it.
Okay. So, explanatory is, that's the, candy or berries, right? Please don't say I'm wrong. Don't say I'm wrong.
Yes. No, you're right. Yeah. It's the candy or the berries. Correct. You're good.
Yes.
Perfect.
And then pasta's response.
And then, yeah, the response is calories. Then is response, right?
Okay. Oh, just calories?
Yeah, it's just calories.
Yeah. Oh, yeah.
Yeah.
Because they're given unlimited.
Because that's what you're measuring. You're measuring whether, so the explanatory is whether they get berries or candy, right? And then the thing you're measuring is the amount of calories they eat, which in this case, right, if they eat berries, they eat less calories, probably because of the fiber.
So the experimental units in this, I'm kind of confused because, or wait, no, experimental units would be.
I think it's the people. I think experimental units refers to who you're testing, which in this case I think it's just the people.
Oh yeah, okay, so then it'd just be like.
It's like the trees, right? The trees in the other one. Yeah, okay. Oils and inflammation. The extracts of avocados.
Oh, no, it's all good. You don't have to do that one. It's only to 53.
Oh, okay, cool, nice. So we're done.
Okay. So what would? Yeah. Okay, but what would the treatments be? So I'm kind of confused on like.
For which one?
53.
The treatments would be either you ate pasta or either you ate berries or you ate candy. Those are the treatments. It's also the explanatory variable.
Could you define treatment for me?
Yeah, treatment is like.
Confused.
Yeah. Okay. Let's see. Like, what is a treatment in statistics? Yeah, the specific thing applied to a group. Okay. So it's similar to the explanatory variable, but the explanatory variable is more generic. The explanatory variable would really be like what food they were given before the pasta, and then the specific treatment would be berries as a treatment and then candies as a treatment.
Okay.
Yeah, I would say like explanatory variable contains treatments. Does that make sense?
Yeah, that makes sense.
Okay.
All right, man. I really appreciate you always helping me out. And,
yeah, for sure, dude.
I'll be back. Trust me, I will be back. I got some physics I'm going to need some help with, all right?
He'll be back.
I really appreciate it, though.
You're welcome,
Really appreciate it. You have a good one.
Come by anytime, dude. I'm happy to help you, man, dude.
All right, you take it easy.
Peace, bro. All right. Let me see. Dun, 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 dun. Nice, good job. Too small. Always got some fun questions there. Statistics. I think he needs help with physics. Let me read some of the chat. Sorry. For development stuff like that and non-local runs, I use cloud. But for a lot of stuff in the future, imagine we have like local models. Because if the internet fails, oh, I see what you're talking about. Yeah. Because I was gonna say, you know, why don't you just have Google predict whether there's trees on the road or not? But you're right, that is contingent on there being cell service or internet, right? You need Google to at least run their servers to help you. I'm curious though. Wait. How does this quantum mechanics thing detect if there are trees on the road and let other cars know if there's not any signal? How's that working? Like, where are you getting your data from, Freedom? I'm just curious. Car scanning. I'm trying to read his. He was talking about some cool stuff here. I'm glad you're safe after Helene. Helene was kind of a mess. Dr. Gold, are airlines stock good for gaining money within 2 months? I don't think like technically I'm allowed to give you guys any financial advice. That's why the guy says like I like the stock. Oh, it wasn't smog. Sorry, it was Swaz. So I had the wrong one. Whatever, smog. You get an extra Mon coin. Let's check one. There you go. Okay, cool. Okay, let's see. I know we have a bunch of questions. Can you do mine? Yeah, Bosnian, I'll help you. Well, I think I did yours, Bosnian. Yeah, I did yours yesterday. Let me see. Where is the... Let me see the schedule. We got a lot of people today. You fell asleep? Oh, Bosnian. Yeah, shouldn't you be asleep right now, dude? It's quite late for you. Okay. Let's help Bosnian because he is in Bosnia. I feel for the Bosnian. And then Taco Cat, you're next. And then Lost in Saga. And then Equity at any point whenever you want. I'll help you with yours. Let me but yeah, airline stocks, yeah, probably good. Except like when I did them during what was it? 9/11. That was bad. I was in elementary or middle school and we had like a stock market competition and we had to pick stocks and I ended up picking a bunch of airline stocks right before 9/11 happened and everything just crashed. I need 1 point. That's why I'm here. Okay. All right, Bosnian. I'm glad you need 1 point. Okay, Bosnian, which one do you want to do? You want to do C? Yeah, well C's actually kind of easy. Here, let's do A. Do you know how to do A? Let's see if you can do this one. I think I did this yesterday for people, but it's okay. You fell asleep. You're awake now. Okay, how do you do it? Show me, Bosnian Dragon. What time is it in Bosnia right now, actually? Curious. It is 1:50 in the morning. Wow, it was late. Okay, yeah, these are a bunch of radicals, Bosnian, right? Yeah, how do I add these radicals up? One thing that might help you, anytime I see this and like there's not a number in front of it, I'm just gonna move it over a little bit. I'm gonna put a 1. Sometimes that helps. We do like 6 plus 1. Yeah, exactly. Good. So this is a square root of 2, and this is a square root of 2, Bosnian. So that adds up to 7 square root of 2s. So that's what we kind of say, right? We got 6 root 2s. I have 1 root 2. Add them up. Now I got 7 root 2s. What's another pair I think I can maybe add up? 2 minus 3. Very good, Bosnian. Yeah. I got 2 root 18s minus 3 root 18s. That's going to be negative 1 root 18. Now, here's the thing you probably missed. Do you know that you can combine these two? Do you know how to combine these two? I got 7 root 2 minus 1 square root 18. You might be worried at first, right? You might be like, wait, these don't have the same thing, right? can't usually add or subtract square roots when they don't have the same number inside the house. But there's a trick. Do you know the trick? Keyboard want to work today? No? Okay. That's okay if you don't know the trick. Okay. This is called, as I learned yesterday, SURD. S-U-R-D. So we're going to split this, okay, into factors. What do you know are two numbers, Bosnian, that multiply up to 18? What are two numbers that multiply to 18? What's up, Dennis? You got some astrophysics for us to do? Nine and 2. I like that. Okay, cool. So I'm gonna say 2 and 9. All right. And then I can't really split 2 anymore because it would just be like 1 and 2, but that doesn't really count. So I want to see if there are any other numbers I can split. I can split this 9, right? What can I split the 9 into? I took my retake for my second exam in physics, and I was wondering if we could go over them. That's okay. Yeah, that's fine. 3, good. 3 and 3, right? They both go into 3s. Okay. So here's the trick, Bosnian. Anytime, and watch, see how we can't split this anymore because it's 3 and 1? That's not really splitting it down anymore. You want to be able to split it in numbers that aren't just 1. You're free of astrophysics? Okay, cool. Anytime you have a pair that you find, you can then pull that pair out and put it in the front. And anything that's left has to go back inside the house. All right? So this whole thing here becomes -2. Or, sorry, -1, sorry. Not -2. I don't know why I said -2, sorry. -1 times 3. And then back inside the house, anything that's left over, that's going to be the 2. Okay? So now, once we pull this down, right, Bosnian? I have 7 root 2 minus 3 root 2. Yeah, that's the trick. This is called, yeah, this is important to know this. Okay, so what is this going to be? Last step. Good. 4 square root of 2. Nice. Good job, Ozian.
Well done! Well done!
Nice. 10 bond coins. Sweet, man. Yeah, just buy the tier 1 in the store. DM me what gift card you want, and I'll send it over to you in a couple hours. Yeah, you're very welcome. Glad I can help you. Okay, cool. Let's see. Equity? Do you want to go over your question, Equity? You're technically next in the queue. Sure. All right, let's do it. And then technically if Taco Cat's here, and then Critical, I got you. Lost in Saga, and then 1K, and then Ethan. Although I think 1K said he was going to work. So we'll see. All right, partially filled pool has 10,000 liters of water. Ooh, wow, okay. Finn begins to fill it with a hose on a hot sunny day. The volume in liters of water coming out of the hose is given by this. The volume E in liter of water evaporating is given by this. Oh, okay, cool. Let P be the total volume in liters of the water in the pool m minutes after Finn started filling it. Okay, so P, and they want it in terms of V of M and E of M, right? Okay, so it starts with 10,000, right? So we have to put the 10,000 here, Equity, okay? And then what do we do here with the V of M and E of M? I was hoping this would be like a fun differential equation, but it's not really. Well, I guess you could. You could figure out dp dt. I might have to explain text the problem because I won't be able to send a message in the help chat. Yeah, that's okay, Dennis. Yeah, good. Exactly right. Yeah, so this would be plus, well, when they say V of M and E of M, yeah, this would be plus V of M minus E of M, which is then equal to technically plus 20M minus 0.1M, right, which is just equal to plus 19.9M. Yeah. Yeah, that's not too hard. The next thing you're going to get into when you do calculus equity is you're going to see like, okay, cool, that's what it is as a function of minutes. But what's the rate at which it's rising, for instance? And in this case, you get like dp dt. And so you have to take this dt. And, well, this is basically 19.9t. And you would get that dp dt is equal to 19. Have you taken any calculus yet, equity? I don't think so, right? And this is a rate. No? Okay. Well, this is little intro. This is what this is. So, calculus with derivatives, this is called a derivative equity, has to deal with the rate of water entering the pool in this case. Derivatives is all about rates. And the opposite to that is this, which is technically like an integral. And that's equal to the total water in the pool. So they're two different things. So you see how you can measure like, oh, the amount of water in the pool, right? That's equal to 10,000 plus 19.9 T, okay? So at any point T, I can tell you how much water is in the pool. But if I want the rate at which water is entering the pool, that's what the derivative is. And this is a very simple example because it's very linear, right? Because everything just is, when I say linear, there's no like T squared or, I don't know, T to the negative fourth or square root of T. So it's very easy to solve. But it can get more complicated. So here, I'm going to show you the one where it gets more complicated. On our Discord somewhere. Where is it? Oh, wow. Already up to 4K. Nice. Okay, I'll take 4K. This is it. Here's how to solve for related rates. So here we have an inverted cone with a radius of 5 inches at the top. This is cool. This is the calculus of rates and stuff. So this is, for instance, you have water in a cone, and the level is like changing at a certain amount, and you want to know how much water is flowing out of it. In this case, we're trying to figure out. And it ends up using a lot of geometry as well. You end up using similar triangles, and then here, these are the rates I was talking about, right? Like dvdt, dpdt, or something. Once we have our two rate variables, this is where this gets cool. So we're gonna get to this. This was kind of an easy question, but in the future, yeah, let me teach you a little bit of calculus. Because what's the next class? What's the next math class you're taking next year? I don't want you to get bored. I know you're just taking like English and like whatever. Like stuff sucks. And I guess you're doing something with stocks. It's called advanced functions. Is that like algebra 2? Is it pre-calc? What's advanced functions? Here. What is the advanced functions class in Canada? Let's see. Okay. Oh, okay. So this is basically pre-calc. This is pre-calc. Because they're doing, yeah, polynomials, logs, and trig. But there are no available spots. I mean, it's not too bad. Yeah, if you want to know about, yeah, polynomial functions, trig functions, we've done logs, right? I've helped you with logs. What's up, Al? Or Stephanie. Yes. Yeah, please, please, please. Yeah. You can type it out. If you want to type it out, Dennis, in office hours, or you want to type it in the chat. Most of that is review. Yeah. Honestly, I would just skip this class, dude. Like, you should just go straight into calculus, and anything you need help with, I can just reteach it to you. You know, for stuff getting into calculus. Oh, 1K's back. Okay, cool. All right. Anyways. All right. Good question. Equity. Let's move through some of the other students.
Well done. Well.
Oh, Dawn's here. It's a Dawn raid. What's up, Dawn? What's up, Dawn? Yeah. Dawn does math. Dawn does math. Dawn does physics. Dawn does it all, dude. Oh yeah, dude. What's up, Dawn? Shout out, Dawn. Yeah, you like the Valorant. I love the new clip, dude. Yeah. Yeah, it's just something random, but yeah, I felt it. It was very apt with you. Yeah. Yeah. Shout out Dawn. Dawn's a great guy. Also does awesome math help, math exploration. He does some physics, and he plays Daisy. Yeah. Hey, Femvox, did you ever see that Eddie Murphy movie called The Golden Child? That movie was great. Are you sure that's not a biography about me, dude? Yeah. What's up? What's up? That's hilarious. Yeah, good to see you. Good to see you, Anders. What's up, man? Let's see. Who was I gonna work with next? Taco Cat. You in the house, Taco? Eddie Murphy is the perfect person to play you. I do like Eddie. He's cool. What has he done recently, Eddie Murphy? Yeah. Okay, if Taco Cat's not here, I got Lost in Saga. Critical, you here? We're gonna do some physics. Don's favorite. Yes, he's here. All right, let's do it. Oh, the new Beverly Hills Cop. You're right. Yeah, they did bring the new Beverly Hills Cop. Yes, and then 1K, you're next. And then I'll help out Ethan or Dennis. And then we'll do some more for Stephanie. Oh, Taco Cat. Okay, Taco Cat. I'll do yours right after this. Okay. Okay. A ring has a uniform charge density of lambda. I want to know how to get the bounds. Okay, well, that's just this, right? Isn't it this? So we got like circle, right? And then, I don't know, what's this, right? And, whatever, there's a bunch of like this stuff, I think. Is this how it works? I think it's how it works. And you end up like going all the way around. I need to watch the new ones. I haven't even seen them, honestly. Okay, electric potential. I believe that's the integral of KQ over R. Or do I gotta cross something? I forget if I gotta cross something. Okay. I think it's K integral of Q over R. Or it's like DQ over R. Yeah, I think that's what it is. K integral B to A dq over R. Yeah, exactly. And then dq is equal to lambda dl, I believe, right? And then the bounds... Oh, wait. I think I know how this works. Yeah, okay. It's lambda dl, which is then equal to lambda rd theta. Or it's like d phi, I think. It's like d phi. Why is lambda rd theta? Oh, because dl is rd theta. Okay, so, yeah, on a circle... This is how arc length works, guys, right? Okay, if I have... This is R, and I want to figure out what, like... Yeah, integral dl, right? Just the perimeter of the loop. Yeah, I agree. And then I'll show you that there's a sine and cosine term that, like, cancels out in the x-axis or something. So, this right here is called... Let's say this is L, right? Or actually, no, let's say this is, like, dl, right? So we know that arc length, right, is equal to the radius times the angle. I'm going to call this phi. So then dl is equal to insert. Let me make this like a little easier. Sorry. Okay. Let's do it this way. I need like more room. Okay. Here we go. This is R. This is L. This is theta. Or I'm gonna call this phi for now, okay? Now, that's like a single arc length occurring. Whenever we do integrals, what we're doing is we're taking little infinitesimally small chunks of this L. So usually, right, arc length here would be equal to R times phi. So if I want the change in the arc length, like the little piece of the arc length, let's say like the dl part of it, I just take the derivative of both sides, right? And that becomes dl is equal to, so dr is 0, right? If I were to do the product rule, because radius does not change. So that's a constant, so I can pull that out. And then this becomes d phi. Yeah, we got Dr. Cook, Fembox, the whole fam. Yeah, what's up? Does that make sense there? So that's where dl becomes r d phi. Okay, great, awesome. Okay. And then lambda, right? This is like q per length. And then this is like the length. So that's why that becomes dq. But yeah, as whoever said, yeah, Dr. Cook said, yeah, everything just comes out at the end of the day. Because when we're measuring like d phi, for example, that's like this angle. This is like d phi. Can you explain the lambda? Yeah, sure. Okay, so lambda is equal to q per unit length. Okay? So, d lambda, I guess. Is that what I want to... I don't want to really say d lambda. This is like a density, is what it is. This is like a density. Okay? So, dq is equal to lambda dl. You could also move this over. Like, watch this. You can move the L over, right? So that you get Q is equal to lambda L. And then dq is just lambda dl. Because lambda is a constant. Like, the charge density doesn't change. Yeah. Okay. So, and then R, this is interesting. R actually changes, right? Find the electric potential passing. So usually there's something I need here, right? Usually this is given in as a function of like x is what we say, okay? We usually say the distance from the center of the ring, all right? So in this case, R, well, this is like big R. This is big R. And then this radius right here is little r. Is equal to the square root of r squared plus x squared. It is 3D. Well, it's a ring. Rings are 3D, right? X is equal to z. Sure. Yeah, you want to call it z? We can call it z. I don't care. Yeah, let's call it z. Okay, whatever. This is z. Okay. And then what we're integrating around, right, is going to be just from 0 to 2 pi. Because I'm taking like every little... I'm going all the way around this circle. Okay, so I have k integral from 0 to 2 pi. And then dq is lambda little r d phi over... the square root of r squared plus z squared. And then here's where the other thing comes into play. So electric potential is a wait. Is it a vector? Or am I thinking does the electric field cancel out? Yeah, exactly. Yeah, because you start at 0 and you go all the way to 360 degrees. Yeah, no, I don't think... Yeah, no, I think it's just done. Yeah, it's a scalar. Yeah, thanks, Fembox. Yeah, so I think this is it. If this was the electric field, this is where this gets a little bit weirder. Because then electric field is a vector, and what ends up happening is that all the components in the horizontal direction cancel out, and you only get the vertical component. Which means you end up, like, having to call this, like, theta, and then it's, like, cosine of theta. Yeah, one sec. I know where this is. Hyperphysics, ring of charge, field. Yeah, this is the cool one. Yeah. I love this website. I don't know if anyone else has, like, used it before. Where's the one where they had it? I want the... Yeah, nah. Yeah, okay, cool. Yeah. Here, check this website. This website is great. I love hyperphysics. It's old school, but it's awesome. I think what I want is this. Ring of charge, electric field. It is this. Yeah, it's this. Yeah. This is the fun one. Old school, that's my school. Yeah. So if you end up doing the electric field, which is it's the step up that they do, you then have to account for the horizontal component going away. I don't really like how they write this. This is really messy. Where's like a nicer way of doing it? I've shown it to people before. Because you have to use like sine and cosine. Is it this one? Nope. Where is it? Yeah. It's like this. Whatever this video is. This guy probably does it correctly. Let me see if this, let me see if his video isn't trash.
Welcome to Lecture Online, and now we're
Oh
going
god,
to try and
he's
find
using
the field.
It's 11 minutes. Oh no.
To the linear axis.
Okay. This is a good explanation. Okay, good. He's at least okay. Yeah, I like what he's doing here. He talks about how the electric field only points to the right, and so you need the cosine of theta. Yeah. Okay. Here, you guys like YouTube? Yeah. Go watch this video. That's the next thing that's gonna get asked for you, is the electric field. Potential is easy. Electric field, when we start dealing with vectors and directions, that's where it starts getting like hard. So that this question comes up all the time. So yeah, take a look at it. It's fun. The bow tie too. Yeah, that guy's hilarious. Anyways, does that make more sense? Yeah. I mean, well then this is an integral you have to do eventually. But nothing here depends on phi, right? So all of this just comes out as a constant, and then it's just a 2 pi. So you just get 2 pi. So you get k 2. Or here we go. 2 pi k lambda r over the square root of r squared plus z squared, which I think was the same thing we have here. Yeah, except yeah, they put little r instead of big R. That's dv. Where's this? Yeah, k lambda 2 pi big R over the square root of r squared plus z squared. Nice. Good question, man. I like that one.
Well done!
All right, nice. Cool. All right, next up, Taco. Taco, I said to help you out. What's up, Taco? What do we got going up here? Scientific notation. Ooh, I like scientific notation. Let's see. Taco cat here. Taco cat. Taco cat. Americans eat an average of 1.2. Jesus, this is so many like. So many hamburgers. I want a hamburger now. I'm really hungry. Equity, show me something. One sec. While I wait for Taco Cat to come up. What's this? Calculus and vectors, grade 12. Yeah, what's up with this equity? Is this a class you want to take? Yeah, rate of change. Cool. That's derivatives. Yeah, derivatives. Yeah. Yeah. Vectors. Wait, they put probability in your class? Excuse me? Oh, this is weird. Oh, it's called mathematics for college technology? Exponential functions. One sec. What is this?
Nice.
Okay, here we go. I want to see what the classes were. Okay. Oh, you went all the way to page 101. Oh, these are the different classes you can take. I see. That's the calc course at Arithmetic School. Mathematics is a different course. Yeah, take the calc course. That looks like a pretty standard calculus course, man. Thanks for the follow. Extreme Bullet Twitch. Bullet Twitch? Bullet Witch? Okay. Taco Cat keeps leaving me. Okay. Taco Cat says I'm not here. No. You're lying to me, Taco. Taco, do you want help? Go away, Olaf. Are you actually here, Taco? Don't make me wait.
What are you doing? What are you doing?
Me? Just hanging around.
What are you doing?
Okay, cool. You are here? Nice. Okay, cool. All right. Let's see. Americans eat an average of I don't know what this is. Is that 1.2 trillion? Billion. It's billion. Sorry. 1.2 billion pounds of hamburgers each year. Assuming each hamburger is a quarter pounder, how many hamburgers okay, cool. How many hamburgers do you eat per year expressed in scientific notation? I like that. These are good questions. So what we always ask, right? I say like question mark, what are we looking for? And this look, I'm looking for question mark hamburgers are equal to 1, 2, 0, 0, 0, 0, 0, 0, 0, 0 pounds. Okay? A lot of hamburgers we're eating here. All right? I don't know. We're hungry boys, the Americans we are. I like to then multiply this by the factor here.
Who got baby voice for me? What's up, Me Machine Rex? How you doing? Me Machine is mathematics. Is that your server? I forget. Penson just briefed me on it a little bit. Okay. I say that 1/4 of a pound. So we say like 0.25. That's American. That's per American as well, right? So that's a lot. Yeah. Oh, per American. Oh, I want
number of hamburgers. No. We want total American. Do per American? This be way too much, Don. Okay. All right. There's 0.125 pounds in a hamburger. I know you're good. You're good. I like the joke, John. I appreciate Don. I appreciate the joke. Okay. Not too much for me. I do like burgers. Actually, I'm more of a hot dog guy. I feel like burgers don't really have much taste, but you're right. You can accessorize them better. I'm going to BK more. All right. In order to put this into scientific notation, okay, this is a big number. We're going to have to like move the I want to put this in scientific notation first because it'll just make my life easier. Not pulling my weight. Yeah. So here's the decimal. And what I'm going to check is how many places I need to move the decimal in order to get it to be scientific. Scientific notation requires that I only have one number in the front of the decimal, and then you can have as much as you want here on the right. Okay? Right now, we have a lot of numbers to the left of the decimal. You're only allowed to have one number to the left of the decimal. So what I'm going to do is I'm going to move this one, right? Which is going to be moving 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we moved it 9 to the left. I do like a corn dog too. Yeah, hell yeah. they've started selling pickle corn dogs at the Disney next to me. I need to do this. What is it? Pickle corn Disneyland. Yeah, bro. These are next level, dog. I need to get one of these. Okay. Let's just like, oh my god, that is such a high resolution image. Yeah, so they now do pickle corn dogs at Disney. What will they think of next? Candy corn is disgusting. What? Okay. Here's my rule, Taco Cat. I call it lurd. I know we learned about surds yesterday, which is apparently a word for irrational roots. I call this like lurd, which is that left, up, right, down. And what that refers to is if you need to move the decimal place to the left, you need to move the exponent up. You use Lars. Okay. What's that? Oh, left, add, right, subtract. I like that. That's another cool one. Yeah, that works too. So this right now is times 10 to the 0. So this was whatever this, like times 10 to the 0. So we went 9 to the left, which means we're going to need to add it up by 9. So now this becomes 1.2 times 10 to the 9th times 1 divided by 0.25. Yeah, Lars sounds better. It's an actual name. Lurd just sounds like weird. But honestly, the weird stuff sometimes sticks better. Like, I don't know. Quick little thing, Taco Cat. Do you know what 1 divided by a quarter is? Like maybe if we wrote it like this. You see how maybe that's like a simpler thing? It's 4.
Perfect.
Yes. So I'm going to rewrite this whole thing as just times 4. Okay? So I have 1.2 times 10 to the 9th times 4. That's going to give me 4.8 times 10 to the 9th. And so, yeah, that's it. 4.8 times 10 to the 9th hamburgers. If we want to know that, like, per person, so I believe there's, like, what's the population of the U.S. right now? Is it, like, 400 million? Oh, 346. Okay. 346 million. Okay. So we could say this is the same as 346 times 10 to the 6. Which is actually cool. I actually like this. Watch what we can do here. If we move this decimal as well, watch. Let's move this over. 1, 2. Okay. Now this makes this 3.46 times 10 to the 8th. Okay. These numbers are basically the same. Like 4.8 and 3.46. I don't know. That's like maybe like 1.3 or something. So I can say this is 1.3. And then 10 to the 9th over 10 to the 8th. This is an exponent rules. So this is just 10 to the 1. So on average, the average American eats 13 hamburgers per year. That seems kind of low, honestly, right? 13 hamburgers? I feel like I eat 13 hamburgers by myself on, like, July 4th. Anyways, okay, cool. Does that help you out there, Taco? Yeah? That make more sense? Yes? Cool. Awesome. Great. Good job. All right, 1K, you're up next. Then Ethan, and then Dennis, I'll do your word problem. And then Zach, I see you did something. And then Stephanie, I'll do stats. We're going to run through a lot. I'm going to make this a long stream. We're at 2 hours and 20 minutes. Moving and grooving. Is anyone else streaming today? So by the way, if you ever want to figure out if someone else is streaming today, we have a website that I put up. Just go to calendar.actual.education. I'll put the link here in the Discord. HTTPS. So if you go to this website right here, which I built, it has Penn Center's put us all together in a nice little calendar. So you can see everyone who's streaming. Oh, nice. So Zach is about to stream. Awesome. So we'll raid Zach after this. Yeah. Or feel free to hop over, go say hi to Zach if you want. Because we're probably going to be another half hour answering all the student questions today. But here's a calendar. You can see all the different times. It looks like, did Penn Center move his Wednesday stream to Thursday? I feel like he did. Because he used to be on the same time as me on Wednesday. But anyways, the beauty of this is it's always updated. And if you ever want to, see if you can click on here, and then here's everyone's Twitch address too. So there's, there's Dawn, there's Penn Center. So we make it really easy for you to be able to find help when you need it. Because I'm not streaming all the time, but with enough of us, we cover like the whole spectrum. Okay, let's see. Is 1K here? Okay, in the house. Yo, he says. Okay, cool. Nice. All right, let's do yours. All right, here we go. All right, the length of a rectangle is 5 inches more than twice the width. Yeah, thanks, Fembox. Yeah, and we're always looking to add more people. So if you know other, math or science streamers, please send them our way, or at least refer them to Penn Center. And he can, we're a very welcoming community. We're just trying to, like, help people. So, yeah, feel free to send them our way. We'd love to get them on the calendar, if they do cool streams. A website, yeah, that's my website. That's my personal website for my nonprofit, but I just built a page to run the HTML code to show the Google Calendar. It's not the official whatever web. It's my nonprofit webpage, but a lot of students ask me like, "Oh, I need help, Dr. Gold." I'm like, "Okay, but I stream Monday, Tuesday, Wednesday. I don't do Thursday, Friday, Saturday, Sunday yet. I might start doing Sunday." So that's a way for you to figure out who else from our wonderful math streamers are online, and that's a list of them all there. So make sure go give them a follow. All right, 1K. Let's try to do this. Says the length of this is called taking word problems and turning them into what's called like algebraic expressions. Okay. So what I always like to do is identify like what our variables are. So I, for instance, have the length. We're going to call that L. And then I also have the width. I'm going to call that W. And then I have the area, which I'm going to call A. So we got three variables, right? W, L, and A. And we want to write out algebra, like math equations that relate to what's happening here in the word problem. So the first one we have here, right, is that the length is 5 inches more than twice the width. How do I write this as an equation? You know it involves L, and you know it involves W. But, like, what goes here? This would be if the length was equal to the width, right? How do we show that the length is 5 inches more than twice the width? Okay, close. He says L equals 5 times 2. Close. Okay. So the length is 5 inches more. When something is something more, that means plus. Okay? So I know right away the length is 5 plus. Right? That's the 5 inches more. Let's color code some stuff. I like colors. Colors are fucking dope. Yes. Okay, good. 5 plus 2W. I agree with that. Right, good. This is the 5 plus, and then twice the width. This part right here, that's the 2W. Okay, L equals 5 plus 2W. And then they tell me that the area, right, is 168, right? So area is equal to 168 inches squared. Nice. Cool. I like the purple heart. You like is it Mimi She Rex? You like the purple heart? Okay. They want to solve for L and W. Do you know how we go? How do we proceed next? We're trying to get, right? We're trying to ask ourselves, what is L and W? How do we solve for this? Because first of all, I got 3 variables here, right? I got L, I got W, and I got A. That's like, I don't like that. There's a trick here. I know the area is equal to something. Yeah, it's okay you don't know. So what is the area equal to? We know it's equal to 168, but what's another thing that area is equal to? Length times width. Oh, that's funny. The Nightbot said, womp womp. Yes, good. Okay, this is the same thing as area, right? Is the same thing as length times width. So now I can replace this with length times width. Okay? Now you have a systems of equations, okay? Because I have this equation and this equation. And there's only two variables, L and W, L and W. Two equations and two unknowns is solvable. The amount of things you don't know, you need at least that number of equations. And also they have to be technically linearly independent equations, which means that like they can't be just copies of each other. Okay. Do you know what to do next here? 1K, once we have a systems of equations, what do we do once I have this? Here, let's get rid of the units. I don't care about the fucking units. I gotta solve for one of these things, right? They kind of set it up for you pretty nicely here, 1K. Because what they did is they already gave you what L is in terms of other stuff. Okay? So you can take this thing for L, and you can end up plugging it in to this L. So when you do that, this becomes 5 plus 2W. That's what this whole thing became. Times W is equal to 168. And now you have to just do some expanding. There's probably a quadratic here somewhere, right? Okay. So we multiply the W through on both. W through on both. I get 2W squared plus 5W is equal to 168. This is a quadratic now because you have W squared and W, and then you have a number. If this thing were gone, then we could just easily solve this. This would be really nice. But because this is here, it screws things up. The way to solve this is to then move this over to the other side. Okay, so let's do that. So now we have minus 168 is equal to 0. And now, you can solve this using the quadratic equation, which is going to be messy. I'm going to graph it just because, I don't know, I feel like that's like the easier way to do it. And also, like, let's use technology. Let's see how it works. So if you type in 2x squared plus 5x minus 168, and you graph this, we should see it intersect. Okay, there it goes. Very cool. So let's zoom out a little bit. Good. So it equals 0 at two different positions. The one we're concerned about is the one here on the right, because that's the positive solution for W. Okay. You can calculate where that is by going second calc, hitting intersect. Oh, actually, not 0. Sorry, not intersect. Sorry, let me clear that. Sorry. Second calc 0. Left bound, just pick something, you know, I don't know, to the left of the function. So you can pick like whatever here. And then to the right is like over here. Guess. And it finds that, okay, cool. W equals 8. All right. So if we did this with the quadratic formula, you'd probably get the same thing. W equals 8. And if W equals 8, what do I do next to find L? 1K. Once I've found out that W is 8, what do I do? You got one of the variables. Plug it into the equation. Yes. Now you plug this back in to here. 5 plus 2 times 8 to get L. And that gets you 5 plus 16 equals 21. L equals 21. W equals 8. And you're done.
Well done.
Nice.
Well done.
Awesome. Thanks for sticking around. Let me have out Dennis. Because Dennis hasn't... What's going on here? Let me see this. And then Ethan, I got you. You're next, okay? Appreciate you all waiting. Let me see. Okay, I think we're talking about a pendulum here. Okay. Dennis, can you... Is Dennis around? I'll just ping him anyways. I'll read it. Okay. I was wondering if I can stream the work as well. Okay. How do you want to stream the work, Dennis? Do you want to be on the VC? Do you want to control the whiteboard? Do you have a stylus? That's gonna be my question. Do you have a stylus? Because otherwise, it's impossible to write this with like a mouse. Oh, okay, cool. Here, let me get you the. Here, I'll get you the link. Here, I'm gonna DM it to you, Dennis, so I don't make it like public. How do I DM you?
Nice.
Oh, I gotta add you as a friend. I'm gonna message you. There. That's that, and then let me say username. There you go. That's how you can access the whiteboard. And just, yeah, good. Okay, let me grant you presenter. There you go. You can write now. Use F to be able to draw. And then S is like to select. You can also use the tool stuff down here. Should help you out. Let me know if you can write. Pretty sure you should be able to write. Okay, it says you have two pendulums on two different planets. Planet 1 has gravity of G1. Planet 2 has gravity of G2. Where G2... The flaw in this math is that gravity isn't proven and densities are proven, so there's no point this plate gravity pull. No, you should be on the right page. It should show you on page... I think if I move the pages, it should move it for you too. So there's no point. This planet gravity pull in a real world setting, yeah. Yeah, page 36, I think, is the page we're on. What's up, Bad Nintendo? What is a pendulum? That's a cool question. So a pendulum, Aced, is anytime you have like something like this on like a string, and it like goes back and forth. That's a pendulum. Yeah. Or wait, is he writing somewhere else? I don't know. Here, let me do something actually here. Let me delete all this. Or hear me. One sec. Let me clear all these pages. Delete all pages. Okay, and then let me. No, that's not it. One sec. And then I need to pull in your screen. Oh, it was in this actually. It was one sec. Okay. There we go. Okay, now can you see that, Dennis? Yes, there we go. We got a check mark. Yes, check mark. Okay, cool. Awesome. Great. Cool. All right, you write. Show me what you want to do. This is cool. I always like when students can like actually use the whiteboard. It is a spinning object based on metals that were not measured when creating, as the metals likely have a different property, heavier on one side. Yeah, I mean if they're molten, they're usually pretty sane. Point A, given G1 and G2. Good. I will tell you, Dennis, you're pretty damn good for writing with your mouse. I'd be awful at this, dude. G2 equals X G1. Okay, so that means that tells us G2 is bigger than G1. Simple pendulum. Yeah, nice. Okay. And they want the ratio of the pendulums. Good. Omega equals 2 pi f. I agree with that. Equals 2 pi over t. Good. So omega equals square root of g over L. I agree with that too. Yeah, so for t is equal to, yep. Yeah, 2 pi over t1. Wait, one sec. Omega equals square root of g over L. Let me just make sure this is right, sorry. Yes. Yeah, the other way to write this, I mean, people typically like to write it this way. They would say, like, T1 is equal to, 2 pi square root of L over G. Yeah, that's usually how we like to write it. But it's okay. Yeah, the way you're doing it is still fine. Nice. That's good. Okay, cool. Yeah, and then that's gonna be something else. Yeah, good. G1. G2. Good. Uh-huh. Good. Yeah, so everything cancels. Yeah, nice. Cancel. And then you just get, I want to say square root of x. Basically, right? Yeah, square root of x. I agree. Yeah, because everything else is going to cancel out. This thing's going to come on the top, and then the G1's going to cancel with the G1. Okay. What's up, Zero? Yeah, almost. I'm almost. I got like 1 or 2 more questions to go through, and then I'll help you out, Stephanie. Is that cool? One or 2 more. I think I just have Ethan's actually. I think it's just Ethan. Yeah, just Ethan. Then you're next. Part 2. Now there's a simple pendulum on the second planet with the same G. Note that both periods and the are equal together. Find the moment of inertia. Yeah, show me this. Oh, yeah. Okay, mgd over I. Yes, okay. Uh-huh. Yeah, you want them to be equal to each other, right? Nice job, Billy. mg 1 over... Now here's my... Sorry, what's this, Dennis? What's this? Is this 1 over 6? What is this? Is that... What is that symbol? Oh, you forgot to add the distance is 1/6 L. Okay, cool. All right, good. Because I was looking at it, I was like, where's the 6 coming from? Okay, got you. Yeah, okay. So the 2 pi's cancel, right? Mm-hmm. 2 pi's cancel. Yep. The L's are not going to cancel though, right? And then G2 is G1x or something, right? Oh, okay, they're both G2. Got you. Uh-huh. Nice. And then you're just solving for I. Yeah, mg16 L squared. Yeah, over G2. Well, and they just want I think, right? The moment of inertia? Yeah, divide by G. Oh, the G2s cancel! Yeah, nice. Yes, good job. I think that's correct, dude. You did it what? You did it right. Yeah, that's cool, dude. Yeah, everything works out. Yeah. Where's the hard part? I say like, was this the hard part? This worked out great. A lot of algebra trick. Oh, I was wondering if I got it right in the exam. Yeah, no. I think you got it right. Yeah, nice. Always happy to, I'm happy that we went through this too, because like, yeah, I had to remember about, I forgot that pendulums had, what was it? Yeah, it was mgd over I. I forgot about this. I know it was like square root of g over L, but you're right. It's the moment of inertia for a pendulum. Yeah, that's cool. Nice. Good job, Dennis. That's very cool.
Nice.
You get a Boncoin for that. And that wasn't your astrophysics class, right? That was your physics class? Yeah, you're very welcome, dude. Awesome. Okay, let's see. I got Ethan. Ethan, what's up? We need help here going. It's physics 2. Yeah, I hate when they start doing the grab bag of topics. Yeah, it's the worst. I know what you're talking about.
All right. I'm here.
What's up, Ethan? Yeah. Thanks for waiting, dude. Okay. What's up?
Yeah, I was writing notes.
Okay.
So yes, this is like quadratic equations then.
Okay. Oh, this is very similar to the last question that got asked. Okay. Do you know how to do this one?
Not really. I've never done word of mouth problems like this for a long time.
Okay. Well, this is similar to what we just did with 1K. Okay. So, like before, always assign variables to things. So let's call this like L. And then let's call this width. And then let's call this area. Okay. Now you want to take there's already 3 things. So you want to take the sentences and turn them into math equations. How do we do that?
You just gotta look at the numbers as well.
Yeah, let's look at the numbers as well. Right. Okay. So we have this. We have this statement, right? The length is 2 feet longer than 3 times the width. How would I write that in terms of a math equation?
Well, wouldn't you write like 2L? Wait, hold on. It's 2 feet longer than 3 times. So you will write like 6L?
Not quite. Yeah, this is the tricky part. This always messes up students. Okay. Whenever you see this, I'm just gonna give you like hints here. All right. Always just write what the first thing is. When it says the length is, you're gonna be like, cool. Length is equals, and that should like make things good so far. All right. This is like saying, for instance, yeah, look, length is, and then we're gonna put whatever else is here. Okay.
All right. Got it.
So it says the length is 2 feet longer. How would I say that the length here is 2 feet longer than something?
What do you mean? What do you mean?
Let's say is 2 more than, right? How would I write that in math terms?
Isn't it like you also have to use signs?
Yeah, you got to use math things like, subtraction, addition, multiplication, like whatever. Yeah.
Or is it like let me see. It says 2 feet longer than 3 times its width.
Yeah, so focus on the first thing first, which is 2 feet longer. How do I say something is 2 more than something?
2 and then the more than sign?
What's the more than sign?
Like
It's not this, not this. It's 2 plus.
what?
2 plus,
Oh,
right?
I see.
Like think for instance, let's say this was
Alright.
like 5, right? 5 is equal to 2 plus 3. Do you see how 5 is 2 more than 3?
Oh, I see.
Okay. It's 2 more than, all right? And then it says 2 more than 3 times the width. Okay, so that's
Yeah.
this. 3 times the width.
All right.
So it's 2 more than something. And then that something is 3 times the width. How do I write that in math?
3W or something?
Yes. So this is plus 3W. Okay.
Oh, okay, okay.
Does that make sense?
Yes, I can see it. I can see it.
Okay, so L equals 2 plus 3W. And then the next statement they say is that the area is 56 square feet. How do I write that as a math equation?
56 S squared or something?
You could just say 56, but I'm going to say A is equal to 56. Okay?
All right.
All right. So now you have a systems of equations, Ethan, right? How do I solve this?
This is a systems of equations?
Yeah, there's 2 equations, right? I got equation 1, I got equation 2.
What? I don't know how to do this then.
Yeah, you do.
I don't know how to define. I don't know where to start.
Okay. Well, here's where we start. First of all, area is also equal to what?
Oh, it's 56.
Yeah, but how do
Right.
how do I calculate area?
Length times width?
Yes. So I'm going to say this is equal to LW, right?
All right. All right.
Okay. Now, one of the ways to do systems of equations is to solve for one variable in an equation
Mm-hmm.
and then plug that into the other equation. You've done this. It's called substitution.
Yeah, I've seen that.
Okay, so I'm going to take this and I'm going to plug it in for did RREF, Dr. L, dude. Yeah, if it was crazy, I'd do RREF. Yeah. So this is just 2 plus 3W times W is equal to 56. Okay?
What did you get? Why did you add a W in there?
So there's a W here,
Yes.
and then this L became 2 plus 3W.
All right.
Do we see that?
All right, I see it.
Yeah? Okay, cool. All right. So now you can solve this, right, by distributing 2W. Oh, nice, Steph.
Plus
Okay, I'll look at it, Steph. Yeah, we'll do it. Okay. Is equal to 56.
plus 3W squared. Yes.
Rearrange this. 3W squared plus 2W minus 56 is equal to 0.
And now you got the quadratic equation.
Yeah, we could. Which negative 2 plus or minus the square root of 4 minus 4 times 3 times negative 56. All over.
Hey.
Yeah, this sucks.
Doesn't matter. It's better that way. It's
I can
better
pull
that
it-
way.
I can pull a 2 out. So I'm going to say negative 2 plus or minus 2.
How did you get the 2 already?
It's a math trick.
How did you do it?
I pulled a 4 out of each thing. So that this became 1
What?
and 1.
Yeah.
And then the square root of 4 is the same thing as 2.
Okay. Then. Huh.
That's
That's a
no.
trick there.
That's a math trick. Yeah, that's some elite knowledge there.
Oh god.
Okay, so then this is 150. This is 168. So this becomes 169.
Which is just 13.
Good. Times 2, right? Which is 26. And then you
What did you
want
get 26 now? Oh.
yeah, 2 times 13. And then you want the positive
I
solution.
never
So
know
I'm gonna
the- Yeah,
24 over
you gotta do
6.
both.
4.
What about
Yeah?
the minus? Wait. What about
The minus doesn't make the minus
then?
doesn't make sense because I can't have a negative width. Right?
What?
You can't have a negative width when you're solving for W. Like negative widths don't make sense. So then if W equals 4, 2 plus 12 is equal to 14. So there you go. So length is 14. Width is 4.
Nice.
Yeah?
Yep, got it.
Nice, good job.
Hey, that wasn't a confusing though. That was a little bit confusing.
It was.
I mean, hey, could you just make a screenshot of this?
Yes.
Well done.
There
You always
go,
type in
Ethan.
random keywords for the screenshot.
I love just trying to get it out. It's okay. All right.
I'm kidding.
All right. Let me see if Zach is around. Sorry, Zach's. Your question is up. Otherwise, I'm gonna help Steph or Stephanie. Sorry. Steph sounds kind of cool. Oh, I was calling you Steven. Wasn't I calling you Steven earlier? My bad. That's my mistake. Yeah, Stephanie. Steph is like ambiguous, I think.
Nice.
What's up, Data Basics? Perfect. What's up, Data Basics? All right. I will see if Zach needs help with this because he's a new student. Otherwise, I will help Stephanie. Let me pull Stephanie's in too. Ooh, okay. I like this. We're going somewhere. There's a lot of stuff going on here. Oh, man. Okay, let's try to get this stuff. Oh, it's calling you Steph? Okay. Oh, it's okay. Yeah. If I was calling you Steven, then that's wrong. Steph is like, it's kind of close, you know? Oh, you thought you were talking about someone else. Oh, okay, cool. Well, your name is Stephanie, so we're talking about you. All right, I don't think Zach's, I think Zach might have left, so I'm going to do your question. Okay, suppose a particular good has a relatively high... What do you want your name to be, Stephanie? You tell me what you want me to call you. What's up, Database?
Perfect.
Your name is Bella. Oh. Oh my god, I am so messed up. Who is Stephanie? Oh my god. All right, I'm so sorry. Oh my god. Bella. Okay, I'm gonna change your name right now so that's correct. Who is Stephanie? I think there was another person earlier on the stream called Stephanie. Or I'm just losing my goddamn mind. Also possible. Can I change your nickname? How do I change your nickname? Whatever. I'll figure it out some other time. Yeah. Like, who's Stephanie? Who the fuck is that? Okay, Bella. Here, Bella. Bella, let's do yours. Okay. Suppose a particular good has a high price elasticity of demand and relatively low elasticity of supply. Okay. So that means demand can change pretty easily. Oh, one sec. I gotta reload this because I've spent too much time. Okay. Can I please get in? There we go. Okay. Draw a properly labeled graph illustrating the market for this good. Label the equilibrium price PE. Label the equilibrium quantity QE. Okay. So this is price versus quantity. I agree. So as price goes down. Okay, cool. You did EP and EQ. Okay. Well, you should say PE instead of EP. Yeah, let's call this PE. Just because it'll yeah. I know you want to say equilibrium price, but it's like price equilibrium. It's weird. Whatever. Okay. Okay. Suppose the government imposes a okay, and we did a supply demand curve, right? Supply demand. I think that's how supply demand curves work. Let me make sure. Supply demand, cool. Yeah, I agree. Nice. Okay, let's keep going, Bella. Suppose the government imposes an excise tax. Label the price that consumers pay as PC. Label the price producers keep as PP. Okay. That would be off the graph then, right? So... Oh, PPR was PP? Okay. So you're saying that, sorry, what is an excise tax? Is that just like a liquor tax or like a tobacco tax? What's an excise tax? Okay, here we go. Yeah, okay. It's just like a tax. It's like a sales tax, I guess, is what it is. Okay. Okay, so I agree. Yeah. That's a good one. Thanks, Toast Wizard, for the follow. Appreciate it. Okay, cool. Yeah, so this is higher, right? And then this is lower. Good. Okay. Well, yeah, let's put this a little bit hard. Let's call this like, let's put like PP here, right? Right. Okay. It doesn't matter. It just has to be lower than equilibrium price, right? Okay, cool. And then yes. Okay, label the new quantity QR. Okay, so that's going to be here. Right? This is going to be the new QR. And then this, I guess, is the tax revenue, right? But the tax revenue is split. Yeah. Because this was the equilibrium, I guess, right? Yeah. And so that's the dead weight loss. Okay. Cool. That's dead weight loss. And then all of this is now the tax revenue. Okay. Okay. And it has a relatively high elasticity of demand. Okay. This has to do with the slopes, right? Which good. Yeah. If it has a low elasticity, that means it's steeper. I agree with that, Bella. And then if it has a high elasticity, then it's going to be more linear, right? Good. Okay. So this one is steeper. Okay, and because it's steeper, yeah, okay. I think that the producers pay a larger proportion. Yeah, I would say that they produce a larger. I would say producers pay a larger proportion because that's this area. So all of this, right, is the tax money. I said that below, but okay. Oh, you couldn't explain? Okay. Okay. The reason being is that, so if there's a high elasticity for demand, right? That means that if the... Right. That means demand is able to move a lot with the price, right? So if the price goes up, those that are demanding it are more likely to pay that amount because it's elastic. Whereas, supply, so if the price changes for supply, it's low elasticity, so it doesn't change very much. Yeah, I think so. Yeah. If instead the tax were collected from consumers, would their burden from the tax increase or decrease or stay the same? Interesting. Oh, this yeah, this is kind of like, this is tricky. One sec. Let me pull this up. Where is it? Not this one. Oh, never mind. Never mind. Okay. Okay, wait. Sorry, I got elasticity wrong here. Okay. So elasticity means the ability for something to shift due to a price change. Okay? So, if demand is elastic, Bella, that means that demand will shift based on a price change, okay? So, if something gets more expensive, then the demand for it will go down, which means that they're not going to be buying as much of it, so they're not going to be contributing as much to the tax revenue, okay? Whereas the producers, right, the supply side is more inelastic, okay? So, what? Oh, I'm using group. So, they can't adjust their supply due to the price. Yeah, okay, yeah. One sec. Let me show it to you, Bill. Okay. So, yeah, here's the key thing here, right? Price elasticity of demand is high. Low elasticity of supply. Let's remember, right? Supply are the producers. Demand is the consumers. If something is very elastic, it means it moves with it, right? So, for instance, concerts are a great example. Concerts get more expensive, people stop going to concerts, right? That's the demand goes down. That's high elasticity. Like, you can think of elasticity as like stretchiness. Like, it'll move a lot, right? Yeah, okay. Whereas low elasticity means that you're fucked if the price changes because you can't change, right? The perfect example for this is gasoline. If gasoline gets really expensive, I can't really stop using gasoline because I need to drive my car. So I end up getting screwed. So kind of think about like who gets screwed and who doesn't get screwed. So Yeah, because the demand is highly elastic, that means the consumers can change their demand to not pay as much of the tax, whereas the consumers get screwed. Sorry, so the producers get screwed because they cannot change their supply based on the price. Yeah, okay. If instead tax were collected for the consumers, would their burden... I don't think that changes, right? I don't think it matters like who it's collected from. Okay, here we go. That's like that's the text output of it. I want you to understand why it is. But yeah. Okay, and then it says were their tax burden increase? So I would say it stays the same. Yeah, the tax burden stays the same. It doesn't matter who gets collected the tax. What's up, Pen? I know we're running a late stream today. I'm about to raid Zach. I'm doing economics. Why? Okay. Because it doesn't really matter. It doesn't really matter who, like who gets assigned the tax. Still changes the price of the good. It doesn't matter who's technically paying the tax, because now the producers, right, still have to sell their thing at a higher amount. Yeah, here's what you can say. You can say that, say this. So economic burden does not depend on who's actually paying the tax, but on the elasticities of it. Yeah. The tax is getting collected regardless, you know? So either like the supply people are going to lose money on producing their shit, and that's kind of like baked into the tax, or the consumers, right, are going to be paying more. Yeah, dude, this is that's hot. yeah. One of our newer students, Bella, is taking a microeconomics class, and so I'm getting my education in for this. Right, you know what the dead weight is? You did that correctly. Okay, and then part F, what one change in your graph would create a situation in which the sellers pay all the tax? So if the sellers pay all the tax, you just make you just make demand perfectly elastic, or you make supply perfectly inelastic. Right. So if you made the demand curve a horizontal line, right? So let's say, let's say this is your demand curve right now. If you just changed that to becoming a horizontal line, then they're going to pay the same price regardless. Like the consumers don't give a shit. Yeah. Yeah, cool. That's kind of a cool question. All right. Does that make more sense? AKA consumers are dumb. Oopsies.
Fuck!
You're welcome. Nice. Good. I hope that helps you out. What's up, Swaz?
Yo, what's up, man?
Yeah, what's going on?
You
got
think you
another
could,
question?
yeah. I just got like, I just got like 5 like free response, super easy. But I just like
Super
if you
easy.
could explain them for me.
Yeah,
I mean,
got you.
I heard you were just about to head out, but
I was good. I'll do it. I'll do it. Show him up.
here,
Show
just
him out.
let me let me
He's gonna get him.
take a little quick picture of him real quick.
Quick pick.
Yes, sir. Yes, sir.
What was it? Zach was asking? Oh, this is called differential
Wow.
equations. Yeah, go see Zach. Go see Zach for his pen. Yeah. I'll be right there.
There you go. Threw him in.
Cool. All right. Okay.
Just
Which ones?
35 through 40.
Okay. A popular website. Blah 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 blah. Okay. Which of the select the best answer? Okay. Simply click the response to join the sample. Do you plan to diet this year? Saying yes.
So it's just this one. I just thought was A. Like it just makes sense. Or no. Don't.
Interesting.
No, that's not right. That's not right.
No.
Let me-
Well. Yeah, Pen Center likes this pen. You want to help me out? Yeah, 35. Oh, sorry. Let me show the whole thing. Sorry. Yeah. 30,000. So the sample is not small enough. That's okay. Voluntary response, I agree, is kind of bullshit. Because, like, people are, imagine you put a poll up being like, are you racist? Like, how many people are going to, like, answer that and say yes?
Me. No, I'm playing.
Is it a convenience sample? I don't know if it's a convenience sample, Pen. Convenience sample is where, like, it's where, like, you sample people, like, because it's convenient. What is it again? Sorry.
So probably about like C would probably be right? I feel like
Here we
C.
go. Well, let's see. What was it? Convenience is based on who is most accessible. Researchers ask people to volunteer to participate. If they own the site, it's a convenience sample. Okay. Yeah, okay. Yeah, okay. No, good point here. Yeah, I like this. Yeah, so yeah, Pen's right. The correct answer here is B. Because B, convenience.
Okay.
Because the sample is being conducted by whoever owns the website, and so they're just whoever is on their website is conveniently answering their thing. Versus voluntary would be asking the whole world, "Hey, would you like to sign up for my sample?" They're only asking people on their website. Yeah. Okay, 36. To gather information of 50 schools from the state. New state was administered to every 10th grade student. What is that? Man, dude. I think it's a cluster sample. Is that a cluster?
Because it's like one state. Or would it be like a simple random?
No, but it's not simple random because I'm not choosing all the students, right? I'm only choosing high schools, and then those high schools have a bunch of students in it. Okay.
So would it be a stratified?
No, I feel like it's a cluster sample.
Do you mind explaining the difference between a systematic and stratified sample?
Yeah. Google does.
Google's got my back.
Yeah, it feels like it's clustered or stratified. Yeah, okay. Dude, what are these pictures, dog? Okay. So, yeah, strata, right, is like dividing into groups. So, stratified, okay?
Okay.
So, stratified is when you break them into groups and then you sample from within the little groups. Okay, this is an example.
So you make like a little subset or something?
So, yeah, say, for instance, you have red people and blue people, right? You split them into red and you split them into blue, and then you're like, I'm going to take 3 from the blue and 2 from the red. Exactly, yeah. Stratified breaks them into groups and then picks from the strata, which is the different groups. Cluster sampling is you start putting them all into different clusters, and then you start picking clusters randomly, which I feel like this is a cluster. Which word is it? Sorry. Fuck. Not tax revenue. Here we go. I feel like this is a cluster because you're testing high school students, but you're just picking clusters of high schools. You're like, this high school, all the students. This high school, all the students.
Random sample from 15 high schools was selected from the state. Oh, because it's just taking like random high schools.
Well, okay.
Yeah, I see. Oh, I see. I kind of see what you're saying because it's like every high school has like a cluster of people.
Yeah, well, yeah. It's because like here's like all the kids. Yeah, Penn Center's right. Here's like all the kids in the school, all the kids in the state, right? And then I'm taking individual high schools. Like this is high school 1, high school 2, high school 3. These are clusters, right?
Yep.
Okay.
Oh, 35 was C. I was looking at the answers. 35 was C.
Oh, they said voluntary, dude. That was my original thing. I thought it was voluntary.
That's weird. I'm just gonna put B,
contest that.
and then I'm gonna ask him. Yeah, I'm gonna put B, and then I'm gonna ask him.
I would contest that. Yeah. Dude, this is a problem with fucking stats, dude. It's all contestable. All right, what's up? 37.
Yeah, 37.
Okay. SR. Oh, I forget how to do this. I think you do 14, 45, 90. I think it's A. Is there some weird rule to this? There's some. So this is called a random. This is like a. They used to have these tables. So before we had random number generators, they would just have these books of like just random numbers. And like it was your job to like, if you needed like 2-digit ones, you'd go 2 digits. Like, here, I'll show you this. It's pretty cool, man. No, not this.
I'm gonna keep it a buck, bro. My sphincter is working overtime right now, so
yeah, this stuff is.
I'm just trying to get this done, man.
Wait, do you have a test tomorrow?
No, I don't have a test. No.
Okay,
Thank
good.
goodness, dude. Yeah, no, I'd be
Clenched.
fucked.
Yeah, so these are like just a series of like random numbers, and so if you want to pick 2-digit random numbers, you do this. You do like these 2, then 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 these 2. I believe. I think you have to move it over. I don't think you do this. Right? Pen, have you used one of these before? Have you used one of these like random number tables? Super weird. Never use this? Oh, they're super cool.
So the answer should be D. I think it's D.
Yeah. We have ChatGPT for this now, yeah, but back in the day they didn't have this. So yeah, bro, they would just have like, look at all these random fucking numbers. Yeah, you would just, it's supposed to be random. There's a whole argument on like what's actually random. Sorry, what did they say the answer was?
No, I don't know. I think it's D. I haven't checked.
I don't think it's D. Oh, I see, but it can only be from 0 to 30. Oh.
Yeah.
Okay. Yeah, okay, because the number 45 doesn't work, and 59 doesn't work, 26 doesn't work, so 05 must be the next one?
Or 03?
Where's 03? Here? Excuse me. What? Why not 05? The hell?
I'm just looking at none of the answer choices have 05.
Yeah, I'm a little confused. There's some weirdness to how you have to answer these. One second, let me find.
That's super confusing.
Let me just see. I'm gonna ask ChatGPT. ChatGPT will tell me. There's just some weird way to read random number tables.
Yeah, for sure.
If a pair is above 30, we ignore. Yeah, okay, where are they getting the 14? Okay, 14, 45, 92, 60. Oh, okay. 92, 60. Yeah. Okay, no, I was okay. Okay, yeah, it is. Because watch this. Watch what happens here. So you
You
have...
just go to the next 03.
Look, 14, 45, 92, 60, 56, 31, 42, 48, 03. 71, 65, 10. 10's okay. 36, 22,
Yep.
53. I don't think you count 22 again. 49, 06. Yeah, answer's D.
Yes.
Yeah, we read it wrong. Yeah, okay. All right, what's up? Up to 40? How many do we have to do?
Actually, you can just do 38 and 40.
39 and 40?
38 and 40.
I don't have all the answers to... Oh, I do. Okay. Suppose, Did the sampling procedure reach in a simple and random set rather focus? Yeah, sorry. Yeah, we don't need the full thing.
I think yes. I think definitely yes.
I don't know. I don't know what this is. Ugh. I gotta run to another student. That's was. I gotta teach. Yeah. Now it's been.
Oh yeah, you're good.
3
man.
hours and 20 minutes. Yeah. All right. Yeah. Try the next one. I don't know. Something there.
I think I know 38
Okay.
anyways, and the 40's light. I appreciate it though, man.
Okay, you're welcome.
For sure. You take it easy.
All right. Yeah, cool. Thanks, man. All right, let's close out the stream. All right. Well, thank you everyone for coming to Actual Education Office Hours. Had a fun time working with all you guys. It is on my Discord if you want, Pen. It's in my. I think it's in the Help Screenshots channel. Yeah, I think he posted it in Help Screenshots. Yeah, it's in Help Screenshots if you want to take a look at it, Pen. I got to run and go teach another student. Anyways, awesome. Thanks everyone for coming out. Next stream is going to be tomorrow. That's an hour later, 5 p.m. Pacific, 7 p.m. Central, 8 p.m. Eastern. And now what we're going to do is go raid one of our awesome math friends. We love our math friends. Go say hi to the wonderful E to the 2I pi, Zach. And we'll see you tomorrow for more help on math and science. Cool. All right. Thanks, everyone, for coming around. Have a wonderful rest of your Tuesday. Have a wonderful rest of your week. And we will see you tomorrow. Okay. Peace.
Appreciate it, brother. You have a good one.
Peace, Waz.
At